Please call. He will join now.
Okay, so what I'm saying is I can create another Zoom which will support 500 students. So I'm not sure whether I'm allowed to do it. I can do it in just quick.
Wait, sir, we will do so. Wait.
Okay.
Mr. Jyoti, I already request the presentation, right?
Sir, excuse me, sir. I have put a link in YouTube.
Sure.
Yeah, a link is there in YouTube. Sorry, chat. I have put a link in chat. Others can join through this link also, sir.
Okay, great, awesome.
Good morning, Krishnamurthy, sir.
Yes, sir. Good morning, sir.
Shall we start the program?
Yes, sir. Direct, sir.
The time is 9:40.
Yes, sir.
Sir, good morning, Abraham, sir.
Okay, sir. We'll start, sir.
Abraham, sir. Very good morning.
Very good morning. Very good morning. Can you hear me? Good morning.
Yes, sir. I'll start, sir. Okay, sir.
The speaker is there is a noise. There is an echo. Can you
I'll
headphones?
Yes, sir. I'll start, sir. I'll start, sir. Yes, sir.
Sir, please mute, sir. Mute all the participants, please.
I have mute all the participants, sir.
Please, sir, please. Sir, please take your.
Sir, I have muted all the participants, sir. Sir, mute panniten, sir. I have muted all the participants. I have muted all the participants, sir. I have muted all the participants. That is already done, sir. Yes, sir. I already muted, sir. Yes, sir. Shall we start, sir? Yes, already they have been muted, sir. No issues.
Yeah, you can start.
Yes, sir. Good morning. Very good morning, one and all present here. Yes. Very good morning, all the participants present here. The Department of Computer Science and Application SRMIST Ramapuram campus is arranging a joint venture guest lecture with IUKL University Kuala Lumpur. Yeah, the Department of Computer Science and Application is hosting a joint venture guest lecture with IUKL Kuala Lumpur. May I now invite our principal, Faculty of Science and Humanities, Dr. Sundar, to present the welcome address. Please, sir.
On behalf of SRMIST Ramapuram campus, we extend a warm welcome to all for the international webinar on applied artificial intelligence in the real world. So good morning to all. So as you know that SRMIST Ramapuram is a well-known university imparting quality as well as holistic education for the past 35 years. So at the outset, I congratulate the Department of Computer Application organizing the international webinar in jointly with IUKL Malaysia for the topic applied artificial intelligence in the real world. So as you know that here in SRM for the past 5 years, we are offering artificial intelligence program to our students as a part of the curriculum, as well as we are also offering as a value added to our student. So as we realize that skilling and upskilling is a mantra of the hour. So each and every day, so there is an intense competition. So to overcome the competition and to enhance our student capability, so we will do all kinds of things to empower our student community. So artificial intelligence, it's not a new terminology to our SRM. Already we are into it, but so the need of the hour, each and every day, the artificial intelligence is spread its root across all the field. So recently we had seen in a paper, so even SFO, so serious fraud office on London, so they applied the AI powered technology in the legal professionals. In that extent, the AI is entered. So there is a big scope for artificial intelligence professionals. Taking into that account, the SRM Ramapuram offering series of programs to empower and to enhance in the knowledge of artificial intelligence. So as you know that here IUKL is one of the global known university. We are happy to that to join and organizing such kind of program. So I also request the organizers jointly you have to organize series of programs for the development of faculty as well as the student. So in this connection, so I extremely honor in welcoming our today's guest. So Mr. Jyoti Periyasamy, Chief Data Scientist, Applied Machine Learning and Data Engineer, University of California, and Chief Artificial Intelligence Architect, Deepsphere AI USA. So, sir, we extremely honored in welcoming you, sir. So, our guest is not a new face to SRM IST Ramapuram. Sir is a mentor as well as the sir played a very vital role in the development of the institution. So, our guest extended support in the development of student community here. So, in all means, we extend our sincere gratitude to our guest Jyoti Periyasamy. So we have a lot of plans to collaborate with the Deepsphere in the future. So SRM IST Ramapuram is also planning to establish Center of Excellence in Artificial Intelligence. So probably another couple of months we are going to establish. Sir, Jyoti Periyasamy sir, we are eagerly waiting for your valuable information, and definitely it will enlighten all the participants in the area of artificial intelligence. Thank you, sir. Thank you very much. I feel honored in welcoming our beloved director, Dr. V. Subbiah Bharati sir, the SRM IST Ramapuram campus. So, sir, the man of humanity, the constant source of inspiration. So, we are also welcoming Subbiah Bharati sir on this occasion. So, it's my privilege and pleasure in welcoming Mr. Jason Andrew Polko, Head International Linkages and Special Projects, IUKL, Malaysia. So, sir, we are honored in welcoming you. So, we are pleasure to meet you, sir. Pleasure to meet you. And thanks for your extended support to us, sir. We will do a lot of miracle in the future, sir. Definitely. We are waiting to collaborate with IUKL and do a lot of good things to the student community. So, welcome.
I'm impressed to see the great turnout today. When I scroll through the screen, 12 screens full of participants in today's event. I think that says wonders about the level of collaboration between our two institutions.
Thank you, sir.
The turnout has been extraordinary. So everybody give yourselves a round of applause for turning out today. It's an excellent, excellent turnout for this event. So I'll just say a couple words. I think partnerships between institutions is incredibly important. Although countries are faced with various kinds of lockdowns and challenges, that doesn't mean that collaborations have to stop. Through online platforms like this, we can continue to work together and share one country to another, share our expertise, share our knowledge, share our research, work together as universities to help the students, to help our own lecturers, to help research programs. There are so many ways that we can work together, our two institutions. This collaboration, this talk, is a really good stepping stone to even greater things in the future. So I'm looking forward to the types of collaborations that we can do in 2021. Hopefully we'll be able to meet face to face and not just on the screen. So there will be opportunities, I think, in 2021 for us to actually have warm body interactions and not just on the screen. So I'm really looking forward to that in the year ahead. So with that, I'd like to turn it back to our host. On behalf of IUKL, I say this is a great beginning to the partnership between our institutions.
Thank you, sir. Thank you very much. So next, I feel honor in welcoming our own Assistant Director, International Office, Dr. Abraham Samuel, sir. So after sir is taken over as the International Office from SRM IST Ramapuram, so a lot of vibrant things is happening. So recent past with 1.5 year, we have collaborated more than 50 international universities, and our pet university is IUKL, because a lot of program is happening with IUKL. So thank you very much, sir, for your constant support to science and humanities and moving to the next level. So our faculty as well as the student, after the normalcy comes in, so we'll do a number of activity to strengthen the international linkages, sir. Thank you very much, sir, Abraham, sir. And it's my honor and privilege in welcoming Mr. Muhammad Hussain, so Dean, FEST, IUKL, Malaysia. So sir is also going to be give felicitation address. Thank you very much, sir. So in welcoming, proud and pleasure, sir, to meet you. And
thank you, welcome.
So I also happy to welcome Mrs. Jabashini Ponnayan, so lecturer IUKL. So thank you, ma'am. So nice to see you. So a lot of discussion we had happened. So definitely we will collaborate and we will do in the area of research and development. We will do a lot of things, ma'am. Thank you. So it's my pleasure in welcoming the program convener, Dr. Diliban, Vice Principal Academic, SRM IST Ramapuram. So as you know that the Department of Computer Application organizing series of activities, so not only for international linkage, so even they will invite a lot of eminent personality in the industry. So we are working towards to reduce the gap between academic and industry. So that is a major vacuum happened. So here SRM IST Ramapuram, so that gap is very minimum. We closely work with the industry and will impact what are the skill set evolved in the industry. Immediately it should reach to the student. So at the outset, I congratulate Dr. Diliban organizing this program as a program convener. So welcome, Dr. Diliban.
Thank you, sir. Thank you, sir.
It's my pleasure. So our director also joined, sir. So welcoming you, sir, for this program, sir. Dr. Subhaya Baru is the director, sir.
Thank you, sir. Thank you, Sundar and Diliban. Thank you very much.
So it's my pleasure and privilege welcoming the participants exclusively from IUKL. It's a kind of a motivation. It's a kind of a vitamin tonic today we had. So seeing a lot of Malaysian faces. Selmat pagi to all of the Malaysian participants. Thank you very much of your valuable time you're spending towards this webinar. We are very much happy. So almost our direct head international linkage IUKL rightly pointed out that so seeing of participant list itself giving the highest kind of motivation. So today we are very happy seeing of both Indian and Malaysian faces. It's kind of integration happening in Malaysia and India. It's a good sign. So thank you for all your time you're spending towards this seminar. So I also welcome our own Indian participants, our students, as well as other faculty members on this international webinar. So artificial intelligence, the topic itself very impressive. So the real-time application of AI in the real world. So we like to know because AI entered all the field, even medical, banking, management, research and development, all the field. But we like to know from our eminent guest, so what else AI is left out and what type of skill set the student should develop if they want to enter into AI industry. So such kind of fruitful webinar, it's going to be happen. So once again, I welcome you all for this wonderful program. So thank you one and all. Thank you.
Thank you, sir, for your wonderful welcome address. It's my privilege to welcome Dr. Muhammad Nasir Hussain, Dean Fest IUKL, to felicitate. Please, sir.
All right. First of all, I wish good afternoon in Malaysia time. Good morning to Indian time. So I think we have about 4 hours difference. So first of all, I would like to congratulate all the team members from our faculties, from electrical departments, and also from SRM. We managed to organize this webinar. And in fact, I agree with my colleague, Mr. Jason. I think now we have on 297 participants. I think quite a big crowd here. So I hope Mr. Jyoti Parasamy will able to share with us their experience and their knowledge. We are really waiting for that what we call speech or talk from Mr. Jyoti, right? So I think I don't want to talk much of this because just now our colleague also mentioned Mr. Jason in the international linkage. So on behalf of the faculty, I would thanks to both IUKL and SRM. In fact, I think this true is what Jabashini says. We already 3 times meeting, I think. So we are keep on very active in organizing this event. So thank you very much. So I just want to hear to share knowledge and experience from Mr. Jyoti. So we are waiting for that talk. Okay, and thank you very much again. So welcome to the webinar, and I will make sure that everybody is what do you call, especially Malaysian students, pay more attention because it's not easy for us to share or to get this what do you call talk. So that's all from me. All right. So I will give back to the host to continue with the event.
Thank you, sir. Thank you for your wonderful presentation, sir. It's my privilege to welcome Mr. Jason Andrew Polka once again, Head of International Linkages and Special Projects IUKL, to give few words about international linkages and special projects. Please, sir, the stage is yours. Jason, sir, can you hear me?
Yeah, yes, I can.
Yeah, thank you, sir. You can.
Yes, I actually don't want to take too much time as well, just for the introductory remarks. I'm really looking forward to the talk to get started. But I would like to say that the university does collaborate with institutions around the world. We ourselves are a very diverse institution. We have students from over 60 different countries attending programs at our university. So one of the hallmarks is internationalization. We believe it to be one of the fundamental principles running the university. So our students, more than 60 different countries. And for academic linkages and partnerships, it spans the range from academic partnerships, so linkages on talks like today, to research collaborations, the lecturers getting together to co-fund research projects and to share expertise. There are possibilities for student exchanges, which will come up in later times, as well as for educational and cultural tourism programs. So I pointed these are excellent opportunities for students to look into if you're thinking about getting some additional expertise in a field like AI, and you think that, hey, I think that this partner university can set up a short 2 to 3 week program for hands-on intensive training in this area. You know, IUKL is an excellent institution to look at for partnering with SRM so that our students can go back and forth between our institutions and share these kind of short course expertise for very targeted hands-on training. And it also allows for some cultural exchange between the institutions. So
yes,
these are a few of the
Jason.
things we do.
Yes, Jason, to answer to your question, yes, we'll have a next meeting with us, I mean, together on 2 topics. One is on research collaboration and education and cultural exchange.
Yeah,
so in which
these are very important.
Yeah, we will have that call. I've already informed my counterparts. So we are organizing it very soon. We'll fix the invite with you and then we'll take it forward.
That's excellent news. And for all the students, don't forget, these are excellent opportunities for you to take advantage of. SRM and IUKL, we're here to help you out, to provide many opportunities. And really, it's up to you as students to take advantage of them the best way you can. Thank you.
Thank you, sir, for your wonderful offering. The functions like joint guest lecture cannot happen overnight. The wheels have started rolling 2 or 3 weeks back. It's my privilege to invite our beloved director, Dr. V. Subbaya Bharati, Director SRM Ramapuram, to give away the presentation. Thanks, sir. Please, sir.
Good morning to all.
Morning, sir.
On behalf of SRM Institute of Science and Technology, Ramapuram Campus Management, once again I express our gratitude to Mr. Jodi Periyasamy, Mr. Jason, Mr. Mohammed Hussain, faculty and students from IUKL, and I place on record my sincere appreciation to Faculty of Science and Humanities for having come out with a wonderful program like this. The topic today, artificial intelligence, is very hot today, but then slightly I will diverge from the core topic, which is technical nature. In countries, especially developing countries like India, in general, there is a pessimistic attitude in AI adoption. Precisely the reason is we think that more than 50% of the jobs will be lost due to adoption of artificial intelligence. So that is a general thinking in the minds of people, especially from countries, developing countries like India. But when you see the reports, it is totally different. I quote 3 major reports. One is World Economic Forum. Their report says that because of adoption of AI, 75 million jobs will be lost. Totally, 75 million jobs will be lost. But by 2022, 133 million new jobs will be generated. That is a good news. Even though some kind of jobs will be lost, but new jobs will be created. Gartner, their report says 2 million net new jobs will be created by 2025. It is sure there will be loss of jobs, but if you look at as a big picture, the net job creation will be on the positive side. So that is a good news about that. So we are gearing up as a reputed university in India. SRM University is gearing up in imparting skills to our own students, upskilling the students and reskilling our faculty members in these areas, so that in the next 10 years, it is going to be a big change in India. You know very well, India is going to be the youngest nation among the world, because our demography says that more than 65% of the population is going to be in the working age group. On the other hand, COVID actually accelerated the digital transformation of industries. So Indian industries are in full swing in going for digital transformation, which will again, the AI will gain momentum in this area. So as a whole, this particular topic today taken up by Faculty of Science and Humanities is a very, very important topic as on date. And I'm very happy about that. I'm very sure that at the end of this program, there will be good takeaways for all the participants. Once again, I wish all of them, and I express my gratitude to all the experts today available here. Thank you very much.
Thank you very much.
Thank you, sir. Thank you very much for your valuable presence, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. It's my privilege to introduce.
Sir, just to add to what Sar said.
Yes, sir.
So, Sar talked about how new jobs are going to be created, how there is a need for new skills, new tools, new technologies, kind. Just to add what Sar said, sorry. Artificial intelligence fundamentally, I'm going to talk about more. Actually, the change of artificial intelligence actually starts at education. Okay. So when I say education, what we teach for student right now, we teach student to make them as a human intelligence. That means either they become a teacher or a police officer or a scientist or a, whatever the role they want to do, they do that role. But
Thank you, sir.
the objective of artificial intelligence don't make student to become a human intelligence, such as become a faculty or a teacher or a doctor or an engineer. Instead, make student to teach the machine, let the machine become a doctor, let the machine become a scientist, let the machine become a teacher. That's a cultural change. That's a fundamental change on how our educational system is built. Okay. I don't know how many of us realized, but that's where we are heading towards. We are heading towards making student not become a human intelligence, make them become an intelligent where they can create artificially a doctor, artificially a human intelligence, such as a teacher, faculties, etc. Correct? That's a massive change in our education. I'm not sure how many educational institutions across the world realize that. What exactly that mean? What we teach per student, it's meaningless. It has no value. It's completely out of scope. Correct? I just wanted to ensure we all understand because we are a very large audience at this point. Correct? So that's a pretty powerful message. Correct? So what we are saying, do not make student to become a human intelligence. Teach student to make them create human intelligence artificially, either as a doctor or as an engineer or as a scientist or as a teacher or as a police officer. That's a pretty powerful statement. Okay. I just wanted to make sure we are all on the same page. Thank you.
Professor, in that case, AI will take over human intelligence in the future. So we will depend on AI in future. So machine will take over the human race.
See, the machine will take over the human race. That's one point agreed. But who can create such intelligence? Again, that's a human, correct? So if I have to create another doctor, I had to know how do we create another doctor? How do we create another 100 doctor, 1,000 doctor? So that means the learning objective, it's not someone to become a human intelligence. The learning objective now, you train the students so that the student can go and build doctors artificially. The students go and build scientists artificially. I think that's the need. We still need human, correct? We are not getting rid of human, but the approach of teaching, the foundation for teaching is fundamentally changed right now, correct? So there is no expectation a student become a doctor. There is no expectation a student become a scientist or a police officer, correct? That is not what is expected. Instead, let the student learn and understand, become a scientist who can create 100 doctors, 1,000 doctors, 1,000 police officers, correct? Artificially, that's the need. We still need human intelligence.
It's my privilege to introduce the chief guest of today's function, Mr. Jyoti Periyasamy, Chief Data Scientist, Applied Machine Learning and Data Engineer, Inspector, University of California, Silicon Valley, USA. He has 17 years of management consulting and end-to-end AI and experience with Deloitte E&Y KPMG. He has over 50 plus clients across industries like health, energy, oil and gas, public services. He is teaching data sciences, applied machine language, and data engineering at University of California, Silicon Valley, USA. He is teaching at MIT, head of AI architect at Expert5, Harvard Innovation Lab. He co-innovates in an industry solution along with SAP America. He published on finance, AI, big data, IIoT, cloud, and SAP appliances. He has delivered many research projects on market for AI enterprise services. He is globally recognized as keynote speaker, spoke at 50 conferences, added one more jewel to his crown. He has been recently invited by Prime Minister Office of Dubai, Malaysia, and Montreal. He is an alumni of Stanford University. He has a lot of credentials from Massachusetts Institute of Technology, Office of the State Treasurer, California. His most recent speech engagement is with Dubai. He is globally recognized keynote speaker and thought leader for finance, AI, digital, IIoT, big data, and data science by Force, TechCrunch, Mashable, CIO Review, and many organizations. He has been invited for a keynote speaker address in many countries like Dubai, Canada, USA, Malaysia, and Australia. And he has having vast in the industry experience in oil and gas, energy, health, and public services. And he has been invited in many education institutions like SRM University, Anna University, SSN, VIT. With this small introduction, I now cordially invite the chief guest of today's function, Mr. Jyoti Perisamy, to handle the session. Thank you, sir. The stage is yours. Of course, we are all impressed by the profile what we have. Definitely, ourselves and students will try to reach your goals. Thank you, sir. The stage is yours.
Thank you, sir. Thank you very much. I really want to thank SRM, especially Dr. Philippin. He has been. Sir, can you keep it?
All the participants, please mute your mic. All the participants.
Sir, you can unmute, sir. Jyoti Perisamy, sir, you can
unmute.
unmute.
I did unmute right now, actually.
Yeah,
Yes,
no
problem, sir. So first of all, I really want to sincerely thank SRM for giving me such a wonderful opportunity, especially Dr. Dilipan, who has been working with me almost last 8 months. And we have been talking, we have been hosting several events, and this turned out to be one of the big events like the last event. Thank you, sir. I'm not ignoring anyone else from SRM, especially the director, the dean and principals, and Vijay madam, Krishnamurthy sir. All we're sincerely thankful for all the effort that you put forward to get this one. At the same token, I'm not new to Malaysia. I actually worked with Malaysian government in 2 different events. Actually, like I'm just trying to show you that. So one is with MDAC, Multimedia Development Corporation. So that's the company which is responsible for digital transformation. I worked with the CEO. I built a digital transformation for the government of Malaysia. So it was a 1-week engagement for me while I was at the Harvard Labs. I did that. I also came on public television in Malaysia, correct? So I don't know exactly what this new channel is. So I was interviewed in Malaysia, okay? And I also worked with the HRDF, Human Resource Development Board, to develop the, they wanted to build some type of a curriculum for the students. I worked with them. And recently I'm working with Uniton. So it's a university based, I believe, close to your campus. We signed an MOU. We are doing a research project jointly. And it's a very big initiative for us as well as them. So we are launching an energy efficiency, energy benchmarking program across Malaysia. So basically educating the Malaysian citizens, how do we save energy, how do you reduce energy cost, and how do you consume energy less. So it's a special program in collaboration with the government of Malaysia, University Uniden. So we are going to launch this program across Malaysia. We just signed the contract yesterday, and we are looking forward to working with you. So that means I will be in Malaysia in January. So I'll be coming there and working from there as well. Actually, okay. Just want to share with you what I have been done for the government of Malaysia, especially citizens of Malaysia. Actually, all right. With that said, let's move on to the session. So the topic for us, applied artificial intelligence. So basically, I'm sure a lot of you heard about artificial intelligence. There's no doubt. And a lot of sessions you may have already attended. This is more focused on how do you apply artificial intelligence in real world applications, correct? I'm currently in 3 projects. One of the projects is pretty massive project. It's a worldwide, it's a company of $40 billion. So due to COVID-19, there are certain things we are doing to understand what product is required, when, where, how. It's a predictive model and also revenue prediction. So based on impact and how much revenue we are going to get. So these are all very massive level projects that I'm currently working on. So coming back to our session, so what exactly we want to achieve today, correct? So our goal today, deeply understand how artificial intelligence applied in business processes, in what form, in data science and intelligent automation, correct? So because artificial intelligence, by definition, it is a concept. There's not much to talk about it, correct? Excellent. So I really want to talk about just a few minutes about Deepsphere. So Deepsphere basically, a company based in Palo Alto, and we also have an office in Chennai. So you can look at our website. So this is basically, we have 2 websites. You can see more about it. So one is the Deepsphere.ai. It's a product focused. So this gives you much broader look on how we apply artificial intelligence different business functions. So this is, you could see this our website. Here you can see how we apply artificial intelligence health, oil and gas, energy, consumer, education. Example, the one that we are working with Unitem, it's energy. So this is basically talks about different use cases that what we build using artificial intelligence. So here you could see anything. These are the real client that we worked. It's US-based clients, Centerpoint Energy, Oklahoma Gas and Electric, National Grid, PG&E. So if you go here, there are different use cases, correct? Building profile, how you use artificial intelligence to build building profile. So you can see them. So what is the business case and what's the model has been implemented, correct? So similarly, you have all different use cases with specific to energy. And these are the use cases we are going to roll out to the government of Malaysia in collaboration with Unitem, correct? Like, so you can see all the different use cases. This also has the demo content put here. So anybody who's interested to know more about smart grids, you can go and look at it, how this has been done. So the actual demo is here, so you can take a look, right? Like, so you can see them actually. Anyway, so that is one focus. The second focus for us, it's education. When I say education, so we are launching an educational platform which is primarily focused on for schools. So I'm just going to quickly show you that before I talk about anything. So so what we are launching for, there are two platforms that we are launching for the schools. So this is, as I talked about, education has to we are going to reinvent the education, correct? We means all of us together, correct? So in terms of what we are actually focusing on education wise and how we are going to be involved. So this is just to basically give you an idea in terms of education, what we are doing. And this is our credentials, like, who actually acknowledged our work. Like, this is a US senator, he's a treasurer, mayor, Canadian members of parliament. They also spoke about us, what we done for this one. So basically, we are offering two platforms, correct? One is an intelligent learning management system, which is providing content for artificial intelligence learning. Second, digital transformation. So that means taking your existing curriculum, transform fully in a digital form, correct? So when I say digital form, so that includes your study material, assignment, quizzes, labs, everything fully, completely built on artificial intelligence based digital content, correct? So these are the two core platform we are offering, and this is basically fully on a cloud model. You can see this one. One is we have predefined curriculum for learning artificial intelligence and data science, data engineering. Another one is a digital transformation of, like, taking an existing content and transform it to digital. So we built on three core components. One is the Google Cloud, that's where our labs are. Amazon, that's where we host our solution. We built on SAP business content, correct? So it's highly scalable platform. And this is a platform currently we are, like, launching both US as well as India. So this is about Deepsphere. So I just wanted to quickly touch, and that's the point. As needed, we can give you more information. That's fine. So I talked about this one. I talked about this one. I talked about this one. All right, let's move on. So my today's focus more on industry, not an academic, right? I have a respectable professors and a lot of PhD holders in math and science and statistics and all this different academic side. I'm really not going to spend any time on academic side. I'm going to focus more on industry. I believe, according to Dr. Dileepan and also the vice principal, and they are expecting to bring industry content, industry view to this one actually. So that's my focus is going to be. All right. So at the end of the session, what we really want to gain, one is deeply understand how artificial intelligence applied in business process. Second, what is the framework that we use to apply this in business process? And how do we gain practical skills, correct? Like, right now, what I feel that's missing. And fourth is in-depth knowledge on data engineering. Data engineering is something that, like, not too many people understood. So let's understand this one. Number one, understand how it's applied in business processes. What is the framework? Practical skills, data engineering. So those are the key takeaways I'm sure you will have. All right, let's start from understanding core building blocks of artificial intelligence, kind. So I'm sure some of you heard, some of you may not heard about it, but let's do a level set. Okay, let's do a level set. All right. So in my view, all these are all mysteries. Okay, why do we call this as mystery? That's because we all know the actual terminology. What is artificial intelligence? What is machine learning? What is data science? What is, like, intelligent automation, digital transformation? I have heard about it, and you also heard about it. But what exactly it means to us in the context of artificial intelligence and how it's going to help either from the academic side or a teaching side, Okay, I believe that's is lacking. That's is lacking. So that is why I call it's a mystery. That's why it's called mystery. Let's understand this first fundamentally, then we'll move on. Okay, all right. So I'm sure you all heard about this one, correct? Speaking, reading, writing, cooking, driving, correct? I'm sure I'm going to move on. So what is this? What this tells us? So these are the things in some capacity we do on a day-to-day basis. Okay, we speak to someone, we read something, we write something, we cook something, we make sandwiches, correct? So I'm not saying this is the only thing we do. Some of the things we are doing on a day-to-day basis, correct? On a day-to-day basis, these are the things we do. All right. So what is this one? So if you look at here, driving, who's driving? That's a human, okay? It's a driver. And how this driver got this kind of skills to drive a car? So either through formal or informal training. Medical diagnosis. What is this? So this is a doctor who's diagnosing medical condition of a patient. Okay, how does the doctor get the skill? Either through formal or informal training. Coding or programming. Who's doing this one? A programmer. How did this person gain this one? Okay, so this person gained this one either through formal or informal training. Right? So what I'm talking about, so whatever we do here, okay, whatever we do here actually, so these are all performed by somebody who that's a human. What do you call them? A driver, a doctor, a programmer. How did these people gain these kind of skills? Either through formal or informal training, okay? Either formal or informal training. So what do you call this one? So this is called an intelligence. This is called an intelligence. An intelligence, nothing but, okay, speaking is an intelligence, driving is an intelligence, cooking is an intelligence. So these are the things what you call intelligence. Okay, so what you call an intelligence. So what I'm talking about, there are different type of intelligence. So when we say reading, writing, decision making, problem solving, these are all some kind of an intelligence. If that intelligence is performed by a human, then it's a human intelligence. So how does the human gets an intelligence? Either through formal or an informal training. Got it, no problem. All right. So this was a question I believe someone asked me, like someone talked about it, like, I believe it's the principle. So are we going to replace the human? Answer is yes. In what form? It is more on the task level, okay, not on the living lifestyle, right? So this is basically what I'm talking about. We understand what's an intelligence. We understand what's a human intelligence. Any intelligence such as reading, writing is going to be performed by a human. That's called human intelligence. Now we have an emotional intelligence. And intelligence comes without a training, okay? To do something about reading, I have to go for a training, okay? For example, if someone asks me to read a Spanish book or a Malay book, can I read? No, I don't understand Malay. I don't understand Spanish. So that's because I'm not trained. I'm not trained in this one. So I cannot do this one. So that means training plays a key role. So once I get trained, then I get some knowledge and experience. And that knowledge and experience basically what we call human intelligence. Okay? Because it's performed by a human, the human gains the knowledge through training. And emotional intelligence, an intelligence that occurs without any formal, informal training. You don't need a formal training. You don't need an informal training. For example, when you see a snake, what you do, either you make a noise or you run away or you do something. Okay? For that, you don't have to have a training. That comes out of maturity. Okay? So over a period of time, you gain knowledge, you gain expertise, then you act based on what you see in front of you. You act based on what you see in front of you. So that is emotional intelligence. Let's say when a baby is crying, okay, someone can't just watch for the baby to cry. You try to console the baby and make the baby not to cry. How does that work for you? Is it we go for any training? Did you do anything to get to know more about this one? Answer is no. Why? So that is the maturity level. So based on things that what happens in your life, you learn and understand. So once you understand, then you act when as and when it happens. Okay. So this is how you classify intelligence. Okay? Any intelligence such as a knowledge of skills and expertise that you gain. Okay? So those are all you apply on your day-to-day life. Okay, either on your living lifestyle or on job function. If such, that is called human intelligence. Okay, that is called human intelligence. Keep in mind, it goes across the board. It is just not only reading, writing, decision making, problem solving. It could be anything. So those intelligence comes out of formal and informal training. If you gain intelligence, such as things that happen in front of you, based on that you act, such intelligence may not happen through a training. So those are all called emotional intelligence. All right, we understand an intelligence, we understand an human intelligence, we understand an emotional intelligence. Now, what is artificial intelligence? All right, It's very important to understand. It is an alternate or a substitute or replacement for all these three, period, correct? It is an alternate. Alternate means you are not going to replace the entire human. Okay, some part of this one could be done by a human, some could be done by like a machine. So that could be an alternate or a substitute or a replacement, a complete replacement. So this is basically what it is. By definition, artificial intelligence, it's an alternate or a substitute or a replacement for any intelligence, human intelligence or emotional intelligence, correct? That's what it is. It could be doctor, it could be a teacher, it could be a scientist, it could be anything, anything. That's a broad statement, but that's what it is. All right, we understand that, no problem. What exactly it means from industry perspective, right? So what does that mean in industry perspective? So please ignore wherever you learn, whatever you learn. From industry perspective, when we say artificial intelligence, it's just only two things, either an intelligent automation or a data science. Okay, that's all. Others absolutely have no meaning. Okay, using artificial intelligence, what can you do in industry? You build an intelligent automation or you build data science. There's nothing else you can do. Python, this, that is absolutely nonsense, correct? Have no value. Please do not spend any time on this thing. If you want to teach artificial intelligence, if you want to learn artificial intelligence from industry perspective, from real world, just focus on these two. That's all you need. You learn to build an intelligent automation, you learn to build data science. What is an intelligent automation? An automation that occurs without any human, without any manual work. No human involved, no manual work involved. We'll talk more in detail. What is data science? Data science is nothing but apply science on data, extract hidden insights, correct? Extract hidden insights. So traditionally, we have not done this one. Traditionally, we never done data science. All we done reporting, we run business intelligence, we run data warehousing. So now we learn to do something different than business intelligence, reporting, analytics, all those things, right? So data science is basically looks for hidden insights on data and extracts, looks for hidden insights on data and extracts. So we will talk more in detail. So what I'm trying to say, do not get fooled by people talk about all the other things, right? In industry, okay, in industry, what you can do using artificial intelligence, only two things. Either you can build an intelligent automation or you can build data science. Simple, nothing else. Let's start absolute story. Please ignore, do not waste your time. People are talking without knowing anything about this one. Let's understand what is an intelligent automation, what is a data science. So from industry perspective, from business perspective, when you combine these two, combine an intelligent automation, combine data science, that will become a digital transformation. That will become a digital transformation. Using artificial intelligence, what you can do for industry, what you can do for business, what you can do for real world application, build an intelligent automation, build data sciences, combine these to form a digital transformation. That's all. If you want to teach this for a student, either in the form of a joint venture or projects or research, whatever you want to do, please focus only on these areas. Others absolutely have no meaning from industry point of view. All right. What is an intelligent automation? Let's understand. An intelligent automation, as I explained, an automation that occurs without a human, any manual work. For example, the best way to understand, take the self-driving autonomous car. Okay, if you are into the San Francisco area or in the San Jose area where Google and all other companies are building an intelligent automation, you may have seen this type of cars. Okay, I'm sure if you have an opportunity to drive Tesla, or if you have an opportunity to drive like any other high-end cars, they're all coming up with an autonomous vehicle. That means a car functions without a driver. You don't need a driver. The car drives by itself. How does that possible? How does that work? And this is basically an intelligent automation. What happens when a car goes on a constant speed? It sees a red light in front of it. It stops automatically. It sees a green light. It goes. It sees a yellow light. It goes back. How does it possible? So this is artificial intelligence. How does it work? It is basically applying machine learning technique. What kind of technique it applies? It applies.
Voice is not clear.
My voice is not clear?
It's breaking, is becoming better and worse. I don't know why. Maybe it's
okay. How about now? Is it fine now?
I think the mic is broken.
Yeah, because it's like going better, then after that going lower, like it's not stable.
Okay, my mic is on a full. Actually, I'm at 100%. Can you
Okay,
see my screen? Actually,
now your voice is okay. Now you can hear you, sir.
okay. I don't know what happened. Sorry, I apologize. So, an intelligent automation is an automation that occurs without a human intervention. The best way to understand is like, in a self-driving autonomous car. I was talking about it. How does the car understands when to stop, when to go, when to slow down? It has a built-in engine, which is basically in a machine learning model runs, understands object detection, gender detection, facial recognition, all this different technologies being used actually, correct? This is basically behind the scene. We may not know this one, correct? So this is the best example to understand what's an intelligent automation. So what industries expecting from SRM? What industries expecting from the Silicon, your university from Kuala Lumpur, correct? IKUL. So they are expecting you build student to create such intelligent automation. I think that is the expectation, not just studying about data structure, C program, C++ program, Java program, or Oracle database. None of those, seriously, correct? I'm telling you, correct? All those skills not at all required. This is a skill really need. Who can build an intelligent automation, self-driving autonomous car, just one example. Similarly, you can build any industrial automation, that is exactly what is required, correct? The students are expected to build an industrial level automation where an automation occurs, correct, itself. So this is what I said. It's a next level of education, next level of learning, next level of curriculum, next level of teaching. And this will fundamentally change how we have been teaching education, correct? It's coming. Whether we like it, we don't like it, it's up to us. But it's going to happen regardless of what we think about it, correct? So, all right. So I'm giving some examples, and then I'm also asking you to, you don't have to tell me, okay? You can send me an answer based on what you know. Give me an example for an intelligent automation. The one I told you, it's basically self-driving autonomous car. Similarly, there are hundreds, thousands, millions of examples you can give. So you can send it to me. I have your email. I have given my email. If it's not, I'll give you one more time. Send me an email. What you would think about what are the different intelligent automation that you could build on your day-to-day life. Let's move on. So next is data science. I talked about what is data science. Very simple, applying science on data. What is science? What is data? Okay. So if you look at, I apply the decision tree, random forest, logistic regression, neural net, correct? What is this? So these are all falls under science and humanities, right? So that's what science comes into picture. This is not an engineering discipline, okay? It's not an engineering discipline. So I want to apply decision tree. I want to apply random forest, logistic regression, linear regression. So these are all science and humanity kind of studies. So applying these kind of studies on data. So for example, I have patient information such as patient demographic, patient clinical data, patient fitness data, and patient lifestyle data. So in that kind of data set, I'm going to apply decision tree. I'm going to apply random forest. I'm going to apply logistic regression. Why? I want to extract hidden insights. What kind of hidden insights I'm trying to extract? How long this patient can stay in hospital? That is length of stay. How soon the patient can be discharged, correct? Like at the patient's discharge date, readmission rate, based on the behavioral pattern of the patient, when this patient can come back to the hospital, correct? So that's the readmission rate. So doing such kind of inside extractions, kind that is basically data science, kind. So keep in mind, I'm not automating. I'm not telling the car to drive. I'm not telling the car to stop. I'm not telling the car to go. Instead, I am looking hidden insights on data. Example, we took very complex data sets, patient demography, personal lifestyle, fitness. We took all the data, and that data used in the hospital at the time of a patient admission. I'm going to say the length of stay of the patients, the model runs and predict and tells. So this patient condition tells me this patient will be in the hospital for the next 5 days, 6 days, 10 days. Readmission, okay, this person is going to come back again in a 1 month frame. Discharge, he or she can be discharged in next 2 days. Behavioral pattern, is the behavior normal or abnormal? You see, to do such things, you don't need to be a doctor, and that is what I'm saying. What we are trying to teach the student to become a doctor, not anymore required. Instead, you teach the student so that they can go and find these things through the data sets, or they can teach the machine to find something like this, right? And this is what expected. So when we say data science, what we are talking about, applying science on data. When you apply science on data, you extract hidden insights such as length of stay, read mission rate, discharge rate, behavior pattern. Keep in mind, this is just one example I'm giving. There is hundreds, thousands, millions of example. I'm giving an option. You can look at your notes and Google, whatever you want to do, send me an answer. What is your example for data science? Okay. So summarize this one. Using artificial intelligence, we can do an intelligent automation. Now you know what's an intelligent automation. It is an industrial level automation. Okay. It is an industrial level automation, occurs without a human, any manual work. And data science applies science on data such as random forest, decision tree, logistic regression, linear regression. Then you extract hidden insights, and that is basically like so what we call data science. Okay. All right. So when you combine these two, what happens? It's basically like become a digital transformation. Okay. So combine these two, it'll become a digital transformation. What exactly by definition digital transformation? So take an example, Uber. You take Uber taxi. Okay. So the time you book Uber taxi, the time you get out, there is no human manual work involved. It's all fully built on, based on intelligent automation and data science. What is an intelligent automation in that case? What's it, data science in that case? The transaction that takes place between the buyer and seller. Who's the buyer? You, because you are the one booking the taxi. Who's the seller? Uber. So between you, there is a transaction takes place. That means your credit card has been charged, it's been processed, they give you back the receipt. Okay, so that is basically an intelligent automation without doing anything. Why? It calculates the cost based on the time and based on the speeds, based on the location, etc. So there is no instruction hard-coded or driven to do those things, and that's the intelligence built in. And such intelligence, basically, like it's called intelligent automation. And when you are on an Uber taxi, when you are going on the taxi, what happens? You hit an accident. Okay, so there is an accident. The traffic was dead. So now it's going to recalculate. It's going to do a reforecast. How much time it's going to take for you to get to the destination. Okay, so the taxi came and picked from where you wanted to go, picked the place where you are, and then also went to where it wanted to go. Then it recalculates how much time it's going to take. That's data science. That is data science. It automatically calculates based on the actual current situation, current condition that happens in this one. So by combining intelligent automation, data science, you can form a digital transformation. The key to be implementing digital transformation, you must have to implement an intelligent automation. You must also have to work on data science. Okay, so that is basically what I talked about. Okay? Uber, DoorDash, these are all proven digital transformation platform where an intelligent automation and data science works together to form the transformation platform. So now let's summarize what we understood so far. We understood what's artificial intelligence, correct? Anything that a human does. Either it could be a day-to-day activity, or it could be an emotional thing, or it can be replaced, altered, or substituted, artificially created such intelligence, correct? So whatever intelligence we talked, reading is an intelligence, writing is an intelligence, cooking is an intelligence, problem solving is an intelligence, all such intelligence, medical diagnosis is intelligence, correct? Driving a car is an intelligence, all such intelligence can be artificially created, okay? And that is what artificial intelligence. In what form that is created in intelligence, in industry, in business, in two forms. One is an intelligent automation and second is data science. When you combine these two, it becomes a digital transformation. All right, let's go further deeper, understand the big picture. How can I do all these things? And this is where you have to teach the machine. This is where you have to teach the machine. When you teach the machine is basically acts like a human. Acts like a human, and that is where machine learning comes into picture. Machine learning comes into picture. So in summary, if you want to implement artificial intelligence in a real world or in a business, so how do? You do in the form of an intelligent automation or a data science. When you combine these two, digital transformation. How can I create an intelligent automation, data science, or a digital transformation? You follow machine learning technique. You follow machine learning technique, right? So this is where machine learning comes into picture. As I said, if you go out on YouTube, Google, this and that, you can get hundreds, millions, thousands of information, you get lost, okay? You get lost. In a simple word, where artificial intelligence applied in what form? Only two forms. Okay, all you have to understand, all you have to teach students, all you have to do with your curriculum or whatever you want to do in artificial intelligence, please focus on understanding an intelligent automation and how to build such automation, how to teach this for students. Second, data science. So in order to achieve these two, we have to go and teach machine, and that is called machine learning. Okay, so in a big picture, when we say machine learning, I'm sure again there's so many different words of machine learning you have seen. Okay, anything that you expect machine to do, okay, you have to teach the machine. So when you want to teach the machine, there are different techniques that you have to follow. And these are the different techniques that we have to follow to teach the machine. So the number one, supervised and unsupervised reinforcement learning. That is one type of teaching machine. Second is deep learning. Third is the computer vision. Fourth is the natural language processing. And fifth is robotic process automation. And these are all different machine learning techniques. So what I have seen, people simply think, oh, deep learning is different, machine learning is different. None, please, right? Nothing. So these are all different machine learning techniques. This is how you teach the machine, how you are teaching your son, how you are teaching your daughter, how you are studying yourself. Like if you want to teach a machine, what
Hello.
Hello, sir. Deepsphere Ai, sir.
Froze, the video froze, I think.
Yeah, I think probably some internet issues. Participants, please wait. There must be some internet issues for the guest speaker. Deepsphere Ai, sir, I think he's having some internet issues. He'll be back in another few seconds. Please. The guest speaker will be joining in a few minutes. Please stay tuned.
Can you all hear me now?
Yes, sir. We can, sir.
Yes,
So I'm not sure what happened. Somebody kicked me out. Like, I don't know who took the control. Somebody took the control. They kicked me out from the meeting. I have to rejoin again.
Oh, no issues, sir.
Okay. Sorry about it. All right. So please keep your phone mute. So what we are talking about is like, so what are the different machine learning techniques that we can use to teach the machine? So that's what we talked about. So now let's understand, like, how do we teach the machine? Okay, so how to teach the machine actually, correct? So that's the key. So teaching the machine is nothing but you have to train the machine. How do we train the machine? And these are the different techniques, correct? These are the different techniques that we want to use actually. Let's understand what each one is. Okay, so I'm just going to skip this one. So this is basically, there are different ways to teach the machine, and that is what we want to understand. Okay, so let's start from the bottom up. Okay, robotic process automation. What exactly it means, okay? So under robotic process automation, I'm teaching the machine to understand a business process, okay? So what is the business process? I don't have to tell anything. For example, okay? So in order to do something in a business, correct, such as order to cash, record to report, procure to pay. So these are all different business processes. If you want to, in a simple term to understand, cooking rice, it's a process, correct? What exactly it means. You take rice, clean rice, put the rice in a vessel, okay, add water, heat them, watch them, cook them, correct? So you do a lot of sequence of activity, and that is basically a process. That is basically a process. So what I'm talking about, if you want to teach the machine where the machine can learn and understand a business process, that is basically falls under robotic process automation. I'm sure you may have heard about companies like UiPath, Blue Prism, Automation Anywhere. So these companies say they're robotic process automation. Do not get confused. So robotic process automation, one is instruction driven, second is self-learning technique. Right? The instruction driven is not artificial intelligence. The self-learning is an artificial intelligence. Right? So we do have to understand what kind of robotic process automation we are talking. Are we talking about a robotic process automation where it's instruction driven, or are we talking about a robotic process automation where it is driven based on self-learning techniques? Right? So what I'm trying to say, if you want to teach the machine where the machine can learn and understand about business process, that falls under robotic process automation. So what I'm trying to highlight, in industry, there are companies out there, Automation Anywhere, Blue Prism.
Excuse me, sir, your voice.
So my voice is breaking again.
Like it's kind of far. It's
okay. How about now? Is it fine?
Yes, now it's okay.
Now it's okay, fine.
I'm surprised. Okay. All right. So what I'm talking about, robotic process automation. Okay. So these are the different machine learning techniques. How you teach a machine. Under robotic process automation, you teach the machine to understand business processes. What kind of business process we are talking about? Any business process. It's just not only what I written here. These are all examples. It could be any business process. But the point is, under robotic process automation, the machine learns and understands business processes. It's important to note. Again, I want to highlight, there are companies, UiPath, Blue Prism, Automation Anywhere. So these companies also says they're doing robotic process automation. You have to understand the difference. If a robotic process automation is instruction driven, that is not artificial intelligence. Okay, so that is very instruction driven. Instead, if it is self-learns by itself, then it's an artificial intelligence. All right, no problem. The next one is natural language processing. Under natural language processing, you teach the machine to understand both spoken and written languages. Okay, both spoken and written languages. So whatever you write, whatever you speak, the machine has to understand. How do you teach the machine to understand what you are speaking, what you are writing? That falls under natural language processing, where you do language modeling, sentence classification, word classification, etc. Right? So that is basically falls under natural language processing. In terms of the best example to understand, if you are using smartphones, when you type a text, it automatically forms a sentence. That's language modeling. It models the language, right? It understands what you are typing, it models automatically. So you are teaching a machine to understand both spoken and written languages. That's basically natural language processing. Next is computer vision. What does computer vision does? The name tells vision. Vision is basically what you see. Okay, so when I see something, I can understand what it is. When I see an object, I can understand it's an object. When I see a human, I can say it's a human. When I see an animal, it's an animal. So I can tell these things. How does I do the same thing for a machine? How do I teach the same thing for a machine? That's the computer vision. Under computer vision, the machine learns and understands objects, human, anything around like videos, etc. Right? So that is where you see facial recognition, gender detection, object detection, human detection, etc. So those are all falls under computer vision. Under computer vision, you are training the machine to learn and understand objects, humans, visions, everything. Okay. All right. So what we looked at, robotic process automation, very focused on business process. Natural language processing, focused on speaking, writing languages, natural languages. Correct. So that is what the machine is going to learn. Under computer vision, the machine learns and understands okay, about the vision of a human. What is the vision of a human? When we see something, we understand whether it's a human, there is an animal, there is an object. What is it? Okay? I want to teach the same thing for the machine, and that falls under computer vision. Now, let's say I have general problem solving technique. Correct? It is not
Yes,
a
sir.
vision. Yes, again, voice problem.
Yeah, the voice problem.
Yes, sir. There is some fluctuation in your voice, sir.
Sir, the mic is kind of inconsistent. Goes up, the voice, the volume goes up and down inconsistently, and it's hard to figure out what you're trying to tell us.
Sure, sure. The other option, I can reconnect. That's all I can do. I don't know what to say at this point, actually. So, because we speak all the time.
I thought at first it was on my end, but I checked the YouTube link. It's across all platforms.
Okay. How about now? Now also the same thing? It goes ups and down?
Now it's fine. But just like inconsistent. Sometimes it's good, sometimes it's not. And yeah, that's how it is.
It's surprising. I'm using high-speed internet, actually, like, no, so I really don't know. I apologize.
It's not about the internet. The internet is fine. It's just, I'm not sure if it's the mic or something, because it's all right. We can hear you, but sometimes the voice dips down. Sometimes the voice is okay. That's the problem. It's probably more than the internet.
Okay, so now it's okay, sir.
Okay, so I'm wondering if there's a number to dial in. Also, I could do a dial in. Actually, that's fine. So, all right, let me try. And then if it is not, I don't know what to say at this point, actually, because I never experienced this problem. I conduct meeting all the time, and this is my first time that I'm having this difficulties. So I'm apologizing. All right, so now we understand. Sure. So we understand all the different ways to teach the machine about robotic process automation, natural language processing, computer vision. Now I want to teach the machine general problem solving technique, right? General problem solving technique. So for example, computer vision, hey, tell me whether this is male or female. That is computer vision. Tell me whether it's a cat or dog. That's a computer vision. Tell me, is this going to be like, complete or incomplete image, correct? So like this, I can arrive certain level of prediction based on what I see, correct? So now I'm getting into not any of that kind of problem solving, very general problem solving technique. So how much this person is going to make as a salary, correct? So this person's salary could be $100,000 to $200,000. How much salary of this, job position? Or how much this house is going to sell? What is the price of this car? So these are all, you see, it is not a language oriented. It is a very general problem solving technique. So if I want to teach the machine general problem solving technique, I can use supervised, unsupervised, reinforcement, deep learning. Okay? Keep in mind, there I'm not talking about teaching the machine to understand about an object, about an image, about a voice, or about language or a process. Instead, general problem solving technique, how much the car is going to cost. Is it going to rain today? Is this candidate is going to pass or fail? Is this candidate is going to be admitted to this program, yes or no? See, those are all very general problem solving technique. Is the patient going to live or die? Is the patient condition is going to cure or not? Correct? So I'm talking about general problem solving technique. Such technique, if you want to teach machine on such technique, that should be supervised, unsupervised reinforcement, deep learning. If the problem is quite complex, okay, for example, is the candidate is going to pass or fail? That could be simple. Why? We can look at the candidate's last 5-year academic history, how this person performed, and what was his participation in the class, etc. Then we can arrive at a conclusion saying like, yes, this person will pass. No, this person is not going to pass. That is simple. Now, if I'm going to say how long this patient is going to live, correct? Is it going to be 1 month, 2 months, 1 year, 10 years, correct? That's a complex problem. Why? I have to analyze a lot more data, lot complexity involved. If the problem is quite complex, it's quite intense data oriented, then I apply deep learning, right? So based on the type of problem, you choose between these categories for a general problem solving technique. Okay, I want to teach the machine where the machine can understand and detect and tells every students whether they're going to pass or fail. Okay, every students I'm going to pass or fail. I want to create that kind of a matrix. Okay, final grade matrix. So for that, I could use general problem solve technique. It could be supervised, it could be unsupervised, it could be reinforcement. Now I'm going to teach the machine to solve very complex problem, very data intense problem, and it is quite difficult to deal that kind of solve this kind of problem. Then it's going to fall under deep learning. Bottom line, these are the 5 building blocks to implement artificial intelligence, either in the form of a digital transformation or in the form of an intelligent automation or in the form of data science. Okay? And that's all you need. So each one, its version. Each one has its own story, own technique, own things to implement. It's quite intense, quite complex. All I'm trying to say, if you want to be an expert, subject matter resource, if you want to be a teacher, good teacher on AI, all we have to do, we have to master all these things. Absolutely, correct? So as a theory, I'm sure you know very well. But when it comes to apply in a real world problem, business problem, this becomes extremely difficult, extremely difficult. I can challenge, correct? There are people out there, they say, oh, this person knows everything, this person knows everything. It is absolutely nonsense, correct? It is quite complex. There are many things need to be involved, many things involved, not just a theory alone, correct? So we will study more in depth as we move along. So I will try my best to cover everything, but at a higher level, what you need to know, if your goal is to learn artificial intelligence, apply in any industry, any business processes, what your starting point, learn and master all these things. What it means, how do you apply, how do you implement, how do you basically make it work? And that makes you very highly valuable subject matter resource. This is just an example. All right. So the ultimate goal to teach the student, to teach the machine and create intelligence artificially in the form of an intelligent automation or a data science. That's what so far we understood. Okay. Now let's dive deep, understand what's machine learning. Okay. All right. Same example. We all teachers, we are students. So we go to school, we learn. Okay, we go to school, the teachers teaches the students gain skills and expertise, and then the students become a human intelligence. We talked about it. So what we talked about, you become a scientist, you become a police officer, you become a lawyer, or you become like a doctor or an engineer, whatever the case may be. You are all called human intelligence. Okay, but what we want, instead, teach the machine. Make the machine to skill the same skills and knowledge what you gained and become machine intelligence. And that is basically an artificially created intelligence. So that could be a doctor, that could be an engineer, that could be a police officer, that could be a law professional, it could be anything. It could be a teacher as well, and it could be anything. And that's what it is. Okay. Like a teacher who's teaching students in the field of AI, we need to teach the machine. So the machine learns from what you're teaching. Okay? And that is the skill we have to really have to step forward, teach the students. Okay? So this is just an example for you to compare how it works in the real world. Okay? So in the school or a college or university, we teach students. What happens? The students gain skills and knowledge and expertise. What happened after that? They'll become a human intelligence in the form of a doctor, in the form of a scientist or a police officer or anything that you like. So in the same concept applies in the machine learning world as well. Instead of teaching a student, you teach a machine. When you teach a machine, the machine becomes skills and knowledge and expertise. All right, then the machine becomes an intelligence, and that's basically what a machine intelligence, which is artificially created intelligence. All right, so I'm going to skip this one. We'll come to this one. Let's understand, how do I teach the machine? Okay? As a student, we learn from a textbook. We have a learning material. We have a lab. We have videos. We have audios to watch. Okay? And those are all our learning resources. That is where we learn. How does the machine learn actually? The machine doesn't read a textbook. Okay? Instead, the machine reads and understands the patterns in data sets. So what exactly we are talking about? We are talking about teaching the machine on underlying data. What kind of data we are talking about? Big data on IoT. Okay, so I have seen education institution, I have seen places, people thinking these are all different animals. No, in order for you to implement artificial intelligence at an enterprise scale, you must have to understand the big data and also some extent IoT. IoT may not be in a full scale, it could be optional, but absolutely critical on working in a big data. If you're talking about using Excel spreadsheet, using like this and that, I don't even consider that's an artificial intelligence class. Okay? So big data plays very complex role. Give you an example. In my current project, what they asked me to do, how does a COVID-19 patient behaves? Okay? The patients across different country, different region, how are they behaving at the age of 70? Someone got COVID-19, the behavioral pattern, the symptoms and warnings, correct? That is a study I'm doing deep study, correct? For that, the behavior of the patient is changes from country to country. A Chinese person could be different than an Indian person. An Indian person could be different than a white person, and a white person different than a black person, correct? Latinos, correct? So these are all diversified culture, how people behave. So my job is to understand the behavioral dynamics of each and every patient based on their condition, health condition. So for that, I cannot just only use US-based data. I have to work with data sets in all different countries. How can I work with? That's what big data. That is what big data. I am dealing with people from across the world who has been suffering on COVID-19. Why? I want to understand the symptoms. I want to understand the warnings. I want to understand the behavior at the age of 60, at the age of 70, at the age of 80. It is massive volume of data. That cannot be an Excel spreadsheet, and that has to be much bigger, and that is why we need a big data. So point is, if we want to teach the machine is not going to read from a textbook, or it's not going to a lab or a video or audio, correct? It could be data, but the data that what we need in order to teach the machine, it is big data. In some capacity, you also work Internet of Things, which is Industrial Internet of Things, correct? These are the things you have to teach the machine. Okay, so this is just an example. I'm going to skip, it's not that critical for you to understand. So now the machine learnings from the data, and data plays a key role in teaching and training the machine, correct? So what is the workflow that we have to follow in order to teach the machine? I'm not saying this is how it should be. This is what I do, correct? Different people have different way of looking at it, but this is just basically telling how do you teach the machine? So what we understood, if we want to create intelligent artificially in the form of an intelligent automation or a data science or a digital transformation, the only way you do teach the machine. How do you teach the machine? There are 5 machine learning techniques, okay? Such as robotic process automation, natural language processing, computer vision, deep learning, supervised, unsupervised, reinforcement learning. So those are the 5 different techniques where you can teach the machine. Understood. How do we teach the machine? I need a data. What kind of data? Big data. In summary, that's what we understood. Now, how do we teach the machine? And this is where I was telling education will fundamentally change, correct? So far, we have not understood, okay, we have not deeply understood what is the problem, underlying problem that artificial intelligence should solve, correct? If you see here, in order for me to implement any machine learning model, okay, it doesn't matter whether it's a robotic process or a computer vision or natural language, it doesn't matter what it is. Everything starts from a problem statement. The problem statement will dictate what model to choose, okay? For example, if it is a simple supervised classification problem, for that problem, I can use decision tree, I can use logistic regression, I can use random forest, correct? So the selection of model, it's driven based on the type of problem you are solving. If you don't understand the type of problem that you're solving, you wouldn't know what model to select, So that means there's a clear need in our education system, in our academic curriculum, teaching students about industry business processes, teaching students about a business problem, teaching students about a business cases. That is absolutely must. So the number one, what you have to understand what problem you are solving. For example, if you want to correlate what you do in your school or college. So when you go to your school, okay, so what happens? You have a subject to study. That's a problem statement, correct? That's a problem statement. You have a subject. It could be math, or it could be science, or it could be history, it could be whatever you study. That's a problem statement. So once you have the problem statement, the second is going to be what kind of model I'm going to implement, select an appropriate machine learning model. So this falls under same thing that what we talked about, what technique I'm going to use to teach the machine, okay? So the technique would be a model which understands the process, a model could understand the language, a model could understand the vision, or a model could understand general problem solving techniques such as deep learning, supervised, unsupervised, reinforcement learning. So you pick and choose which one's the best model to implement. That's number 2. Number 3, I have the problem, I have the model, I need the data, collect the data, okay? So that is very key significant role. Collect the data, that's a very key significant role. So once you understand what data and teach the machine, train the machine. So that is basically a technique we have to understand. So for now, you take granted, that is the process. So at the end, what happened? The machine creates a learning algorithm. So for example, what I'm teaching the machine, like how you teach for student 2 plus 2, 4, 4 plus 4, 8. Okay, 8 plus 8, 16. You are teaching the machine. Same way, you are teaching the student, the same way you teach the machine. So now the machine understands based on what it sees in the data sets as a pattern. So once it understands, it creates its own algorithm. That algorithm is called learning algorithm. That algorithm is called learning algorithm. All right. I taught the students 4 plus 4, 8. 8 plus 8, 16. They understood now. Now I'm going to conduct a test. So in the test, what I do, I'm going to ask questions. The student has to answer. Now I'm asking the students, tell me what is 3 plus 3. Okay, so they're saying, yes, it is 9. That's fine, no problem. Tell me what's 9 plus 9. It's 18. Wonderful, good, no problem. Okay, so the students are able to perform. So that's basically test actually. So the test is nothing but whatever you trained. Now you want to test the machine, whether the machine understood or not. Okay, so that is basically test. For example, so when I asked the students, correct, what is 3 plus 3? Someone said 2, someone said 4, someone said 5. So that clearly tells me there is not enough learning here. Okay, so the students has not learned this one. Now I have to go back and see what happens because I'm verifying the outcome. So since the students are not following, either there is a problem in terms of what I'm teaching or in terms of the statement, or you can select a different machine learning model, or you can come up with different data sets, or you can reduce or increase the training the test data sets. Right? There's a lot of different things involved. All right. So now let's assume the model outcome came out well. I'm moving forward. I'm going to deploy the model. Once I deploy, I'm getting new data. I'm going to retrain, retest, re-verify, and then redeploy. It continues like this. Correct? So if you want to understand this better, okay, from your side actually, so you as a student go to school, you have a subject to study. Let's say you're trying to study mathematics. In mathematics, what unit? I'm going to study on unit 1. To study this one, I need a textbook. Now the teacher is teaching you. Now the teacher is testing you. So once the teacher teaches you, you gain knowledge about it. When the teacher tests that time we will know how much you learned. And how do we know? Based on your progress report. Your progress report tells me, yes, you're good to go forward. No, you're not good to go forward. You can go back here actually. If you're good to go forward, then you can deploy the model. And then based on now, I'm done with unit 1. I'm taking unit 2, unit 3, keep on going. Okay. So this is a high level workflow, how you train your machine learning model. Correct. Keep in mind, it is a very, very high level. There are many things involved. Correct. So I'm not saying this is how it is. This is how I do. Okay. Different people have a different way of doing. I just shorten it, make it simple, easy to follow. All right. So what we understood so far, it is really important. So we understood to train the machine, correct, we need a problem statement. Once we have the problem statement, we work with the data. In industry, that's called data pipeline. And that is what data engineer will do. Once the data is done, then the model will come into picture. The model engineer will build model pipeline. Then when the model is tested, verified, then the model deployment come into production. That's done by IT people. Once the model is done, actually model analysis, basically like whatever the outcome comes, that's a business. So this is to tell you how does it work in a real world, right? In a real world, you build data pipeline, model pipeline, data pipeline, model deployment, model outcome and analysis, correct? And this is how you do. Keep in mind, in order to do anything, you are starting with a problem statement. In our current academic curriculum, I'm absolutely positive. I have taught many courses. I've been many universities, many colleges, many lecturers, correct? 100,000, correct? So nowhere in our academic program, we are teaching industry business problem statement as a first step, correct? So you start from, if you are teaching C++, data structure, relational database management, Any processes, whatever you teach, correct, you never start with a problem statement. You directly jump in and teach this one. But in order for you to teach artificial intelligence, either machine learning or a deep learning or a computer vision, whatever the case may be, correct, you must have to start with the problem statement. Why? As I said, if you don't understand the problem, you won't be able to select the right model. If you don't select the right model, nothing will work. Correct? Selection of model, it's purely based on a problem statement. As I said, there are classification problem, there is a regression problem, there is like okay. So association problem, there are so many different type of problem. Each problem have its own model to choose. If the model selection itself wrong, then it's not going to go anywhere. So that is why I want to highlight, correct? Whatever we teach for students, whatever we want to learn, it's all summarized in the form of industry. In industry, we need data engineer. In industry, we need model engineer, applied model engineer. We need IT professionals. We need business professionals. So what is expected from this one? A data engineer expected to build data pipeline. A model engineer expected to build model pipeline, right? Model deployment, all these things, right? Believe me or not, right? These are all very, very difficult skills to gain. It is not an easy skill, right? It appears easy on the surface. When you look at courses like Udacity, Coursera, like, all these things, it's a basic level information that is have no value for practical problem solving skills. It is information. If you want to know some information, you can take those courses like Coursera, Udacity, any of these online portal courses, right? But if you want to go and deal with real world problem, that is completely different. All right. So this is to summarize how and what to teach the machine. Okay. So basically, there are different machine learning techniques. We looked at it. And how do we teach the machine? Use data. What the machine learns, it learns the patterns in data sets. Correct? It learns the patterns in data sets, which is problem solving technique. All right. So this is just in a high level view, what you to understand. So now we understood there are type of intelligence we can build. Okay. So we can build artificial intelligence. So now we are going to talk about what are the different type of artificial intelligence we can build. Okay. So from industry perspective, where we are right now, we are building narrow intelligence. I will explain what exactly it means. So where industry want to go, a general intelligence. Ultimately, where we want to go, super intelligence. Okay, so that is where we wanted to go. Again, these are all for you to better understand where we stand right now, where we want it to be, and how ultimately it's going to turn into. Okay, so what is narrow intelligence? Like we talked about the self-driving autonomous car. Take that as an example. Okay, take that as an example. So in that example, what we noticed actually, so we are basically like, so we are talking about building an autonomous car where the car functions by itself. Okay, how does the car functions by itself? It is basically a built-in artificially created intelligence. It acts like a driver. Okay, the car, inside the car, there's an invisible driver who's sitting and controlling the car. What is that invisible driver? That is artificially created intelligence. All right, what does that intelligence does? It follows the rules and regulation of road and road condition. It follows the rules and regulation of traffic and road condition. Okay, so that rules and regulation, traffic condition, common for across all cars. Whether you drive BMW, whether you drive Porsche, or you drive Infiniti or Lexus, whatever car you drive, the road condition and also the traffic rules are common regardless of what car you drive. If such, why everyone has to build their own autonomous vehicle? Why can't there be one common general autonomous vehicle which goes across the board regardless of who's the manufacturer? What does that mean? It is reduction of cost, reduction of labor, more efficient. So right now, if you look at all the manufacturers such as Tesla, BMW, they all make their own autonomous car. But the underlying intelligence, it's common both the car. Okay, both the car. What exactly that means? The road condition, the traffic rules are common for both Tesla as well as BMW. If such, why do I have to create two different autonomous vehicles? One for BMW, one for Tesla. Why do I have to create this one? Why can't I create a general one? So in narrow intelligence, you have one problem, one solution. One problem, one solution. What we wanted to achieve, okay? We wanted to achieve several problem, one solution, okay? Several problem, one solution. So what are the several problems? Several manufacturers, Infiniti, BMW, Lexus, Tesla, they all will have one common autonomous vehicle engine. So that is basically an example I'm giving where industry want to go. Industry want to go to general intelligence. Okay, industry want to go to general intelligence. Right now, most cases what you see here, narrow intelligence, take one problem, solve the problem. Now, where industry is trying to do, that is more inefficient. We want to create many problem, one solution. For many problem, we want to create generalized solution. The other example, when you go to Amazon website, it tells you the customer who bought this product, they also bought this product. That's a recommendation system. Do you think we can take the same recommendation system what we have in Amazon, put it in another website such as Target or Walmart or a Best Buy? Is that possible? Answer is no. Why? So that's because they have not built to understand the underlying data structure. Okay, the data structure of the underlying data structure of Amazon may not be the same as the underlying data structure of either Walmart or a Target or a Best Buy are different. So that is where industry is leading towards. Build one common solution which goes across the board. What does that mean? Build one recommendation engine which works across different company. That is where they wanted to move. That is where the industry is right now focused. That's the next one. In both the cases, in narrow intelligence, in general intelligence, what we have to train the model. The model training part is required. Okay, what that means, the machine has to understand what is the problem solving technique that I'm going to use to solve this problem. Okay, if I have to recommend something to a customer, how do I know what to recommend? That is basically what the machine learns on a recommendation system. If a machine has to drive a car without a human, then the machine has to understand the underlying road condition. When to stop, red light. When to go, green light. When to slow down, yellow light. How does the machine learn? You have to teach the machine. You have to train the machine. So when it comes to super intelligence, you don't have to train the machine. The machine almost acts like a human. Ultimately, it becomes like a human. And that is where we wanted to get to. That is where we wanted to get to. So in narrow intelligence, you are training the machine. In a general intelligence, you are training the machine. When it reaches super intelligence, it acts like a human without a training. Okay, without a training. So this is just a projection. I'm not saying this is how it should be based on several sources. What I see here, in 2020, we are here very focused on narrow intelligence. In 2025, we're going to hit general intelligence. In 2030, that's a projection. We are going to hit super intelligence. When we reach that point, you will see completely different worlds. You will see a completely different world. All right. So we understand what are the different type of intelligence we can build and how do we train and test the model. So now let's understand, if you want to be a subject matter expert, or if you want to teach these kind of courses, if you want to guide, coach students, what skills are required? All right. So this is based on my industry knowledge. Okay. I'm not coming with from an academic side. I do teach academic courses, but I'm more focused on industry representation. Okay? Even at MIT, as well as University of California, I was teaching more of an industry view. Okay? So I'm not considered an academic professional. So I was considered as an industry experts. So based on industry, if you want to teach, or if you want to become a data scientist, or if you want to become an applied machine learning engineer, or a data engineer, or advanced computing professional, right? So if you want to become any one of these roles, what the skills industry point of view you need, okay? It is critical, okay? So in my view, even if I want to teach the subject, okay, I have to be very thorough in all these things, okay? So, so basically what I'm trying to say, I'm going to skip this one. The skills that are required in order to become a subject matter experts: number 1, business skills; number 2, data skills; number 3, modeling skills; number 4, computing skills. All have to work together. Out of all, I would say the most difficult challenge skill is the data skills. The most difficult, not model building, not computing, not business. The most challenging skill, in my view, it's data skills. For example, if we are building on a product, okay, using artificial intelligence, or let's assume you are going to implement a simple machine learning model, the time you spend on data could be quite significant compared to other skills. Okay, compared to other skills. So, but in order for me to get started with anything, I need a business skills. That is where industry process comes into picture. Okay, without industry process, what happens? You wouldn't know what feature to select for a model. Even if you go for a deep learning, you have to understand what the problem solving technique. Okay, how do you formalize a problem statement, and how do you accept the desired outcome? All of those things matters, right? So
It starts from industry business skills. Actually, that's the number one. It could be health, it could be oil and gas, it could be energy, it could be retail, anything. The second most important skill in this context is data skill. As I said, correct? So we never heard the term data engineer. Now we are talking about a data engineer. What does that mean? Okay. So we have to understand how to work with very complex data sets. For example, in our traditional world, we work with very structured or maximum extent unstructured data. Now everything is data. Like for example, one of the work that I'm doing, I did in the past, and I'm also supporting right now, it is understanding customer behavior. So how does the customer is behaving? So in order for me to do this one, I have to understand if the customer posted any YouTube video or anything that like a video, which is a kind of a feedback, then I have to read and understand the feedback. Or if a customer has posted something in a Facebook, I have to understand that one too. If a customer has posted something, if a customer is basically like talking anything about like Twitter or any other places, I have to understand this one. So what exactly this means? Now anything you touch, it's all become a data. Data could be video, data could be image, data could be voice, data could be a structure or unstructured, it could be any form. It could be any form, okay? How do you work all these things? It's absolutely critical, it's absolutely most important, okay? Teaching this to the students, in my mind, it's one of the most challenging tasks, I would say, okay? So making students understand all the underlying data structure. So far, what we taught to the students, linked list, okay? That is simple. Arrays, that's simple, okay? That is not quite complex. Kind structure, that is simple, we understand. In some cases, relational database management system, talking about tables, columns, primary key, foreign key, all these are all quite easy. But if you ask the student to work on, correct? I have currently students working with me, and I know how much challenge they have, correct? So ask them to work on how do you take YouTube video, connect with like what has been posted on Facebook, and how do you take Facebook and link back to Twitter, correct? Because why it matters, correct? So these are all things that what you need in a real world. So working with such things, it's quite complex, and this is where your big data and IoT skills comes into picture, such as working with Hadoop, Spark, all these different things, absolutely most important. The third is the modeling skill, and this is where you can build your own model or you can implement. Okay, so working with things around either decision tree, random forest, logistic regression, linear regression, CNN, RNN, artificial neural network, all these things are modeling skills. All the things are modeling skills. In my mind, I'm not saying it is quite difficult, but it needs some practice. Okay, so what industry used to think, in my view, industry used to think you have to be a PhD holder or you have to have this and that. In my view, absolutely it's not. It is a neck deep technical skill. Okay, a neck deep technical skill, and that's what you really expected. So if you understand how to build model, train, test, deploy model, how to build model pipeline, I think that's pretty decent, correct? That's pretty decent. So you really don't need to worry about too much about rebuilding model using statistical modeling, like all the things, correct? I do understand you do need that skills, but it's not primary focus of understanding mathematical equations, statistical modeling and calculation. I really don't think it is that critical. You do have to understand, but it's not that difficult. What is really difficult? Building the model pipeline and executing the components of the model pipeline and making that work for you. That's quite intense challenges. The last one is computing skills. Traditionally, what we do, we work on CPUs. Now we have many different ways to work on. We can work on cloud, we can work on GPU, we can build microservices. Okay, it is stateless computers, computing services. Like there is a lot of different way of computing. Okay, it is completely changed. As I said, what we teach for students, building structured C program, C++ program, it is still there's a need, but the actual applications built on different level, different capacity, different type of automation, and that needs a different skills. Okay, so this is where working in a cloud infrastructure, working in GPU, working in microservices, building serverless computing, kind. So all these things absolutely critical. So if we have to be a subject matter expert, or if we want to teach the students, what are the skills required? These are the skills. By having the skills, either you can become a chief product architect or a AI architect or a data scientist or a data engineer, model engineer, or a manager. It's all possible. Even a teacher, it's all possible. So these are the possible industry roles you could expect. Okay, so industry role you could expect. And this is again why I want to talk about this one. Actually, this is because
there is a perception in industry. Okay, so the perception in industry, what the industry thinks actually, artificial intelligence means it's completely different. Okay, it's completely different. Not at all. What is artificial intelligence? It's a reinvention of software engineering. How you build software, how you build automation, that is fundamentally changed, correct? So what I'm talking about, the way we have been building software, it's completely changed. The way we have been building reporting analytics, it's completely changed. Okay, it's completely changed. So that is basically what I'm going to talk right now, correct? So when people say artificial intelligence, do not think it is very heavy duty, like, advanced, okay, degree holders who can sit down and do some research. Absolutely, it's not. Okay, you don't need a PhD, you don't need advanced degree, nothing. If you understand software engineering, it is an enhancement to an advancement to the software engineering. It is the only difference is in a traditional software, we code the business logic. In artificial intelligence, we teach the machine to code the same logic. That's it. That's it. I can tell you, I can prove you, and I can, confidently argue with anybody. There are people out there who says, oh, I'm from Stanford, I can do this one. I'm from MIT, I can do this one. It is great, no question, we respect them. But the need is not that. Okay, need is not someone who's holding higher advanced degrees, not at all. The need is advancing software engineering, taking software engineering to the next level. I think that's what it is. That's what we are going to focus on. All right. So typically what we see, okay, typically what we see in IT's product and service company, we can see different roles. Okay, so
we have a problem to solve. To solve the problem, we create a functional design. We create a technical design. We code, test, deploy, and monitor, and enhance, and all those things.
I don't have to repeat. I'm sure you already know about it. And what is the problem here? It is hard-coded. It is inefficient. It is not going to be something that, scalable. And also, if there's a change occurs, it's not going to understand the change by itself. So this is a traditional software engineering, what we are teaching for students at the moment in colleges, schools, and universities. How does this going to change in the world of artificial intelligence? In the world of artificial intelligence, I'm not going to create a functional spec. Instead, I do feature engineering. I'm not going to create a technical design, technical specification. I do
model planning, model selection, model engineering, data engineering. I don't code. It's basically kind of training and testing the model. This is where it takes place. Test the model, model validation. Deploy, model deployment. Monitor and support, model pipeline, data pipeline, monitoring and support. So none of these roles or none of this function exist in the AI world. Even if it does exist, it's in a different level, different form. And this is a fundamental change I've been talking about. Why I'm doing this one? This is to make human intelligence. This is to make such human intelligence artificially. Example, when we say code, who's coding? A human. Here, I'm not coding. The machine itself codes. It builds its own learning algorithm. Okay, it builds its own learning algorithm. So these are all machine-driven tasks. They are human-driven tasks. Here, the one on the left-hand side is all human-driven tasks. The one on the right-hand side, it's a machine-driven task. So when we want to student to get to this level, what the student has to understand, not creating functional spec, not creating technical spec, not coding, not testing, not deploying, monitoring. Instead, they need to understand these things. Why? No hard-coded rules. What is this? It's more efficient. It's self-learning. How do we prove this one? Okay, so we'll get to the point. So what I'm suspecting, okay, all these roles, who's doing this one? Business analyst. Who's this one? Senior business analyst. Who's doing this one? A developer, programmer, software engineer. Who's this one? A tester, test engineer. Who's deploying, build and release person, support engineer. These roles could be changed in a different level. Okay, so these roles could be changed in a different level. Okay, I'm not saying this is how it should be. This is my view based on what I've seen. So I don't see any reason for this role to continue or exist because I'm doing completely different approach. I'm not creating functional spec. I'm not creating technical spec. I'm not coding anything. I'm not testing manually. I'm not deploying manually. Right? It's all done systematically, all done automatically, all done without any human intervention. If such, I need to learn this one. And this is what I'm saying we should teach the students. All right. This is just to understand, make you understand what I said is real. So traditionally, if you want to read data from a table, what you do, you write a simple SQL statement. So in the SQL statement, you hard code all the things, correct? So this is just to listing all the employees in a particular country tell who are all in the same job title, job grade, or a salary grade. So for that, traditionally I write a SQL. If I want to implement this in a data sets using AI approach, I don't write a SQL. I implement models, machine learning models, statistical modeling technique, such as k-means clustering or KNN. So what is this does actually? It does the same thing. It groups the data and it finds similarity. What is the similarity? Employee who's in the same job title. How many professor? How many assistant professor? How many research scholars? How many post-research scholars? Right? What is that? So those are all similar job title. It groups them together. It forms the cluster. I get the same thing, but here I hard-coded. It is more inefficient. And this is no hard-coded. So tomorrow if I get a different data sets, okay, it automatically figures out by itself. And this is what expected. This is just to make you understand the traditional software engineering and AI-based approach. So keep in mind what you are teaching in AI. You are teaching in AI advanced software engineering to build an intelligent automation to build data science. In that context, you do not hard code any values. Hard coding values is a traditional software. Instead, you teach the machine self-learns. No change, when change comes in, it automatically learns by itself. In the traditional world, when a change comes, you can handle the change. You have to go back and make a change in the code. Here, nothing is required. It automatically built up. Okay, so this is basically summarized. In the traditional software engineering, okay, we do hard code. In the AI-based, no hard-coded business rules. In the AI-based, it's a self-learning technique to adapt business changes quickly. In the AI world, it's a data-driven. Okay, machine learns from the data. The machine learns from the data. So these are the key points for you to consider. So how does the software engineering completely reinvented based on artificial intelligence? Okay, so if we look at, we are going step by step. We understood artificial intelligence, then we understood how actually we can create artificial intelligence in what form. Then we understood machine learning technique. Then we understood type of intelligence. Now we are hitting the point of all the things what we studied. It's leading towards software engineering. That software engineering is basically it got to next level of automation. In that, what is expected, why we are doing, and that is what I'm summarizing. The reason we are doing this way, no hard-coded business rules at all, no hard-coded business rules. Since there's no hard-coded, when there's a change occurs in the business, it automatically understands. It's heavily driven by data instead of a human-written inefficient code, source code. And to prove that, we have an example. In a traditional software, if we have to list all the employees who's getting the same level of salary, same job grade, we write a select statement. In the select statement, we hard code country is this, department is this, all these things. If I have to do the same thing, I will take the same data, run a k-means clustering model or a KNN model, which forms a cluster. What it does, wherever it finds a similarity, it groups them. What is the similarity in this case? I'm interested. Employee who are in the same job title, employee who are on the same department, employee who are on the same, like in a commission, etc. I want to group them. And how do I do? This is how I do. And this is what industry expects, not this one. So if you are teaching this one, this become an obsolete. This become no value. This become no employment opportunity for the student. Instead, they want to understand these things. All right. So I'm just trying to highlight in both the cases, it gives the underlying same data. So one is hard-coded, one is not hard-coded, more efficient way of doing this one. All right. So one last point, then I'll go to some of these examples that I wanted to cover, then I'll close the session. All right. So 1 second. 1 second. I'm just going to skip some of this one. Yes, this is what I want to talk about.
Okay. So what I'm trying to say, this is more focused on education. Okay. So how does the current education, it's going to differ from the future education, which is an AI driven. Okay. So these are all some talking points. I'm not the person who's going to change our entire education system. So based on my interaction, my observation, correct, I'm talking about how does the future education is going to look like. So for example, so if you take study material, it is common to everyone in the class. In the future, the study material is going to be dynamically created at a personalized level based on how you are learning. Second, an assessment. The current assessment, if a class of 100 students, all 100 will have the same question, same assignment, same quizzes, and that is going to change. It's going to be dynamically created, and that's something we are doing right now. course duration. Okay, how long a person can sit in the class, correct? If someone is advancing, we want to advance them. So in the current state, if it's a 6-month course, you sit down in the 6 month, even if you're learning fast, correct, you can move out. That's how the structure is. If you look at the lab, correct, it's a very simple basic lab. But in the future, it's going to be pretty advanced labs, correct? So how do we build deep learning model? How do we work with very large complex data sets? That doesn't work in a simple laptop, simple computer. We need much powerful machines. Faculties, okay? So what I see, mostly one faculty will teach hundreds of students. In the future, it's going to be mostly self-learning with some faculty support. That's an expectation. Right now, I don't know where the faculty assistant exists. If a faculty want to teach a subject, okay, you may have to prepare your own content. So in the future, you can ask for content. Let's say I want to teach introduction to artificial intelligence. So you can post your topic, you will get a PowerPoint presentation or PDF file, which has all the content relevant to the topic. Why? And that's what Google does. When you go and type in Google, it brings back the contents. Okay? So this is just some of the points to understand how the education is going to be in the future. This is just a thought. Okay? So this is basically based on how we are doing. Okay, our current education system, it creates human intelligence. What we want, an intelligence to be created artificially. That's the change we are expecting going to happen. Don't create student as a police officer or a doctor or engineer. Instead, make the student to create such intelligence artificially. Create a doctor artificially. Create a police officer artificially. That's what expected. Learning curriculum. Currently, it is very academic driven. A plus B whole squared. A squared plus B squared plus 2AB. Without knowing anything, I'm doing this one. Now, industry driven. If you look at anything you want to implement artificial intelligence, it starts from a problem statement. That's the workflow we looked at. If my problem statement is wrong, my model selection is wrong. If my model is wrong, nothing is going to work. So in the future, education is going to be heavily industry driven. Learning material, concept oriented right now. In the future, it's going to be very heavily real world application oriented. Learning lab, basic lab, and a human to learn and practice. In advanced lab, so we need to teach the human, right? The human has to teach the machine. So that's a different lab infrastructure we're talking about. Learning approach, our current learning approach, very subject focused, finance, accounting, engineering, legal, medical. But in the world of artificial intelligence, there's nothing like finance and accounting. You have to teach everything, right? You have to teach everything. I don't know how that's going to change, but that's the expectation. Learning level and speed. Our current education learning level, it's very highly matured education at a very basic level. It's quick and fast learning. But the AI-based world, the learning is going to be pretty advanced, very advanced, correct? Doesn't matter how intelligent you are, correct? Understanding all the things and making it work, it's not easy, correct? As I said, right, I have a great respect for all these courses like Coursera, Udacity, Udemy, all these courses, but that's very basic level. With that, nothing can be done. Nothing can be done. Those are all information, okay? Those are all information. With that, can you go and solve problems? Absolutely not. Absolutely not. For that matter, very few places where you can gain such skills. Very few places where you can get such skills. So this is just a comparative analysis between the traditional education, what the education is going to look like. All right. So some of the real world application, then I'm going to stop here. Okay, how do you apply artificial intelligence in different industries? So this is already in our website. You can take a look at as well. So we put all these use cases in the website, correct? For example, if anybody wanted to, okay, if anybody wanted to understand. So let's say you wanted to understand how artificial intelligence in a different world. Example, health, you can click health, you'll see oil and gas. Let's say Malaysia has a lot of oil and gas projects, correct? So I did myself work in Petronas, correct? So that's an oil and gas industry. In oil and gas, correct? If I want to implement artificial intelligence, what can I do? Sick well. When an oil well produces oil, but it
all of a sudden stopped. How do I prevent such well become a sick well? Well modeling, well forecasting, production forecasting, field analysis, okay, well ranking. So pressure profiling. So for example, let's assume you want to implement SQL, select this. So this tells you what is SQL, what model has been implemented. Okay, it has all the insights. Let's say you want to do well modeling, select this one. It gives the business context. It tells you what model has been implemented. So like this, we built a lot of industry use cases. Each of this have its own industry use cases. For example, if you want to implement something for energy, as I told you, go here. So this will take you to our energy use cases. Under the energy use cases, here you could see, right, different use cases, building profile. In a commercial real estate building, okay, so I want to implement artificial intelligence. For what purpose? In order to save energy, in order to reduce energy consumption, how can I do this one? Okay, so this talks about energy efficiency, energy benchmarking, and what model is implemented. So all the things, whatever you want to know, we already have it on the website. You can take a look, right? And that is what I'm going to talk right now. Okay, so what I'm going to talk right now, I'm going to talk about these use cases that's been implemented. And the number one is healthcare. We talked about predicting length of stay, how long the patient can stay, predicting readmission rate, predicting discharge rate, behavioral pattern, lifestyle monitoring, fitness monitoring, health monitoring, correct? Value-based care. If somebody in a hospitalized for 10 days, it doesn't mean that you have to pay for 10 days, not at all. You see what value has been delivered. Out of 10 days, how much cure the patient has been incurred, and pay for this one, correct? Pay for performance, correct? So these are the use cases. In case if there's anyone interested to implement models, building any of these use cases, please feel free to reach out to us. We'll help you. And this is some of the use cases that what we have done for consumer world. These are all real world applications. So we work for a company like Procter & Gamble, Johnson & Johnson, Kraft Foods. So Colgate, a lot of different bigger companies we work for, right? So here we can talk about customer churn, which customer is going to stay with you, which customer is going to leave, sentiment, what customers are thinking about you, what customers like, pricing or criticizing about your product and services, okay? We can talk about this. How many people knows about brands, okay? So you have a particular brand, we want to understand brand recognition, brand realization. So how many people understand about your brand, and who are the target for you to reach out to your brand, location, inventory. So like this, there is so many different use cases we can do for the consumer side. And same for energy, I talked about building profile. Okay, so energy cuts, like there's energy line losses. Okay, so outage, you can predict an outage. And asset management, calculate. So how do you manage an asset? How much asset you have? How do you manage this? Predictive maintenance, fraud detection. Okay, there's a lot of different use cases you could look on this one. Okay? So anyway, all these are all different industry use cases. Okay? So we talked about energy, we talked about health, we talked about consumer. In our website, everything's listed there. You can look at it. So these are all different real world use cases. For these use cases, we have model, we have code block, we have training data, test data, deployment procedure, model pipeline, data pipeline, everything we have. Okay? As needed, we can work, we can take this forward. This is my last slide. Why does a company is doing all the things? Okay, why do a company wanted to go this one? When we ask this question across the board, almost like thousands of companies. So the number one answer why a company want to do this one, productivity. That is why they want to move to artificial intelligence. I agree with that. What does that mean? So if you look at our day-to-day life, I go to my office at 9 o'clock. I come back home at 5 o'clock. Between 9 and 5, I go for 3 coffee breaks. I go for 2 restrooms. I go for 5 phone calls. I have talked to my friends. If you look all the things, the productivity between 9 to 5, it's just only 2 or 3 hours. The remaining hours goes for non-productive activity. So how do we increase this one? And that is the only solution. The only solution to answer the question is create human intelligence artificially. Okay. So example, I'm a driver. I drive taxi. I'm sick and tired. I don't want to drive on this weekend. Or I don't want to drive on Sunday and Monday. It's my choice. So what happened? The taxi company, they're losing money on me because I'm not going to work. Since I'm not working, I'm not making money. Of course, I'm not getting paid. But ultimately, what happened? So the companies loses money. If it's a self-driving car, they don't give a damn, right? They're going there or not. The car is going to function by itself. The car is going to take care by itself. And that is basically increased productivity. It doesn't care about coffee break. It doesn't care about tea break. It doesn't care about cell phone. It doesn't care about sick, mom's sick, I'm sick, this, that, okay? None. So the number one reason why business wants to go for artificial creative intelligence, such as doctors, engineers, scientists, teachers, right? Why? Why? Answer is productivity, increased productivity. The second reason, efficiency, right? So we as a human tend to make mistakes. If you train a machine, if you ask the machine to do, of course, there are ethical AI, so we can talk about it, but If you ask the machine to do a systematic process, it doesn't take any shortcut. It doesn't do anything. It just follows the process, get it done. So the second reason why business want to go for artificial intelligence, it's increase efficiency. And third, cost. Of course, when your cost goes down, your revenue goes up. So these are the reasons why business want to go for artificial intelligence. Okay. Anyway, so very much I'm done. So there's a lot more content. It's going to be quite challenging to cover everything. So I'm already on my time limit. So I'm going to stay here for some time. So in case if there's any question, you can ask me. Okay? Any questions?
Hi. Hello, how are you? My name is Dr. Tadiwa Elisha from UKL. My background is in network security, and I'm so much interested, very much interested in what you have presented to us in AI. But I wanted to ask, say, from the academic point of view, your presentation is perfect and very, very, very good. But I wanted to ask you from your industry, your expertise, and your experience in the industry, in the application side. You did not highlight to us what are the dangers of artificial intelligence. We have seen the good side from your presentation. On the academic side, our quest is to improve and to make sure that everything is perfect. We cannot do that if we do not know what to focus on, especially on the negative side or on the undesirable side of artificial intelligence. I wish you can talk a little bit about that. That is my first wish which I need you to address. And then the second part is this. We are looking at artificial intelligence. And just now you told us that artificial intelligence is more of taking the human side of intelligence, and we are teaching the machines to do it, because machines are almost they are almost like fault. Now I am saying that from the whole process you have just taught us, you have just been exposing us to, artificial intelligence is like one person or a group of people taking a one person's way of seeing things, or a group of people's way of seeing things, and making it universal to solve a problem, teaching machines so that it can be applied universally through machines and computers. My worry is, are we not imposing a few people's ideas on many people, taking away the right of human beings who are less deprived to make those decisions, to use their own mind, and will this not lead to a new form of problems, clusterization of people, fault lines between the rich, the poor, the powerful, the enabled, and the disabled, those who are exposed to these, to make decisions on other people? Because when you are talking of artificial intelligence, there must be some standards which must be followed. Who is going to make those standards? For example, a car is designed in Germany. They are following the standards in Germany, the roads and everything. And it is an AI-based car. I am coming from Africa. That car, I cannot use it because the standards which have been imposed are the standards which are German. So unless Africa is German, then we can apply this. Are we not creating more problems for us and more divisions along these lines? Thank you.
Yes, it's a very
Yes, sir.
yes. Okay, sir. Okay.
Yeah, sir. Jolly Prisam, sir, one small suggestion from my side, whether you want me to want the participants to put the question in the chat box so that I can take it to you, or they can.
Yes, sir, yes. So that's fine. They can put in the chat window. I can take it from there actually. So let me address this question first, and then I can take one at a time. So if I understood correctly, I apologize in case if I'm not clear on your question, but I'm attempting to answer the question that what you asked for. So yes, I do agree. What I talked about is a concept, but I do have in a real world application. If you are from Malaysia, Maxis is one of the very large telecom in Malaysia. So it is similar company. That is a similar company that I implemented this particular solution. It is in my presentation to cover. Since I ran out of time, I was not able to do it. So this is a real application end to end, how it's been built. Example, the actual focus of this application, increase, if you look at here, increase call usage, that is number one. Second, prevent call drops. That means when you are on an active cell phone call, if the call quality is going down, I want the call quality to go down, I want increase. At the same time, the call should not drop, you are a premium customer. So how did we implement? This is the actual process framework we followed, okay? And here it tells you the steps we took or the task we performed and what teams involved. What is the team skill set, okay? The primary skill set and secondary skill set. Second, it also talks about what model has been implemented at a high level. So the first one is basically usage churn, micro segment, target marketing and upsell, financial forecast. These are the model has been implemented. In order to implement the model, so what kind of technical details we used for? We used this system landscape, and this is the microservices we built, and this is a service catalog, and this is the different technology work together, and this is the technical please keep your
Others can keep your.
Sir, please mute Mr. Abdul.
Keep your phone in mute. Please keep your phone in mute, please. So this is the actual, this is the actual technology that's been used, starting from Kafka, HDFS, Alexios, smart machinery model, Yarn, Zeppelin, and how many actual custom machines that work together, and what are the different parts, where this data come from, and also it gives you all the different technology in its detail, and it also gives you how it flows end to end, and how each of the technology got connected, and how much data is being used for. We used connection, usage, okay, all the DPI, financial, etc., and the data frequency, and then the data comes in how much volume, correct? So this is the actual example that has been, I was actually planning to cover. Since I ran out of time, I couldn't go it actually. So this gives you step by step from the problem all the way to implementation, what are the various things we have done, correct? It is, as I said, you could imagine. So this is for 9 million subscribers, 9 million customers. We were able to implement call drops, increasing call quality. So prevent, if there is any cell phone call is going to drop, prevent them, route to a different tower. And second, in case of the tower is bad, the call quality is going down. So how do we prevent that thing, right? So those are the things we have done. So it's a live use cases, and this use case could be applied for any industry. Okay, so that is my first response. If I understood the question right, this is what it is. The second point, what you asked for, so you asked for how do we build policies? How do we build guidelines, correct? If a self-driving car is coming into Africa, what is the standard? What is the guideline? Do I have to have license to drive the car, sit in the car? If the car is met in an accident, who's going to be liable for this one? Who's going to pay for this one, okay? So these are all policies. These are all guidelines. My understanding, the government itself right now aware of all the things. They are working towards formalizing such policies. I don't think any policy already exists in place. But one thing I can tell, across the world, every government, every organization stepping forward to formalize these kind of guidelines, operating principles, processes, standards, policies, okay? That is how I see it, okay? So I don't know whether I'm able to answer the question. You can happy to reach out to me. We can have one-on-one conversation. My phone number is here. My email is here. I'm on Facebook, sorry, I'm on LinkedIn, so you can Google, you can send a request, we'll get connected, we'll go from there. This is my best answer for you.
Thank you.
Thank you, sir. The participants, I request you to post your questions in the chat box so that I can route it to the chief guest. And one more request, all the participants are requested to fill the feedback form available in the chat box. Any queries from the participants, you can please put it in chat box so that I can route it to the chief.
The chat box
Excuse me,
is
sir.
disabled.
Disabled.
Yeah,
I have a question, sir. Can I?
Yeah, sure.
Yeah, please go ahead. Please go ahead.
Yeah, I have the artificial intelligence topic is like it's so broad software topic, but I have two concerns about this topic, especially in the future.
Sure.
The scientists expect by 2024, they said most of the professions will be handled by artificial intelligence. So my concern is, why would we create something that would replace us in the future, and then let's say after 10 years we'll start fighting them back for our life? Like why would we do that to ourselves?
Sure.
That's one thing. Second thing,
so,
it's computer
sure.
programmed thing. So maybe it can get virus or anything. Like maybe it start killing us by virus. Like not everyone wants the good for the human being. Some people are just psycho. So
Sure.
why would you do
So,
that to ourselves?
Definitely. I will ask this question actually, kind. So let's take one example. 10 years before, do you know how many people had cell phones? 10 years before, just a random population. Take randomly 100 people. Out of the 100 people, how many people had cell phone 10 years before?
Maybe 50. Not sure actually.
No, 50 is too high. 50 is too high. I'm talking 10 years before. No, but we should have some sense, correct? We don't need to be accurate. I'm not testing your knowledge on whether you're accurately answering or not, correct? So 10 years before, you select randomly 100 people. Do you know how many people may have cell phone at that time?
Maybe 10.
Around 20.
It could be around 15 to 20%. Okay, so if you select randomly 100 people, so only 15 to 20% had an opportunity to have a cell phone. Now let's take 2020. If we take same 100 people, how many people may have cell phone right now?
2 billion.
90%.
2 billion.
Okay. Yeah, either it could be 100% or 99% people have cell phone. So what is the reason? Why does that change occur? Correct. So where we had only 10 years before, only 15 to 20% of the people had a cell phone. Now all 100% of the people have cell phone. How does that change happens?
Yeah, but cell phone is not changing the human
No.
being job.
I'm not comparing these two together. I want you to understand one point. That's the reason I'm asking this question, correct? So I want you to understand one particular point that I'm trying to get an answer from you, correct? So this is because two things. One is technological advancements, correct? When I say technological advancement, so 10 years before, maybe one or two cell phone company. Now there's millions of cell phone companies. Second, the actual buying power of a cell phone was quite tough 10 years before. Not everybody can afford to buy. Now anybody can buy a cell phone. Okay, anybody can buy a cell phone. The affordability. So what does that mean? There's something drives us. Okay, who can control this? Not you, not me. That is the market. That's the capitalist market. The market drives everything. So that is the reason I said, why people want to go artificially created intelligence. You ask yourself. I told myself, when I go to work 9 o'clock, I come back home at 5 o'clock. Between 9 to 5, my productivity may be maximum 3 hours, 4 hours. That's it. The rest all, I do non-productive activity. Speaking on a cell phone, going for a coffee, going for a restroom, going for this, going for this. Those are all absolutely non-productive work. If you look at any business, whether you work for a business or you own a business, it doesn't matter. Out of all the business, 60 to 70% of the money has been spent on human capital. Okay, 60 to 70% of the money has been spent on human capital. If you reduce that money, that is going to be a significant savings. Okay, so that is the reason we said number one, productivity, number one, efficiency, number three, cost. So these are the driving factors. Who can control? Nobody. Nobody can control, correct? Nobody can control. Why? That sometimes the government itself goes for bankruptcy. The government itself shutting down their operations. If a government who's defining policy, if they themselves going for a bankruptcy, they're not able to operate, how could you expect others to operate? So to solve all these problems, such as productivity, efficiency, cost, we need a solution. We need a solution. And that is a solution, artificial intelligence, point one. Point two, do not simply think it's going to replace people, not at all. It's going to make people more efficient. Now you have an inner fear. I need to learn some new skill. I need to understand some new technology. I need to understand new way of solving problem. That forces gain people new skills. I would say it's a transformation. It's a skill transformation. It's an industrial transformation. It's an industrial revolution. That's all I can say. I'm not saying that it's going to take somebody's jobs and replace with the machine, not at all. So it is a revolution in industry. We need different level of automation. We need different level of skill set. And that is why artificial intelligence comes into picture, to increase productivity, to increase efficiency, to reduce cost. Nothing else behind the scene which drives these things. That's how I see. At the same token, I do understand there is an ethical AI, what to do, what not to do. People are working and defining such policy. It is not matured yet. It will come in the future. It will come in the future. There are certain things you can do. There are things you cannot do using artificial intelligence. That will happen. But I think that's coming very rapidly. People are working towards creating ethical AI. They're doing that. I hope this helps you.
Okay, thank you so much. This was Muhammad Fathi from IUCAL Infrastructure University. Thank you so much for the session. It was really helpful.
Excuse me, sir. Can I have a question?
Sir, yeah, we have few
Yes, sir.
questions
Yes, sir.
in the chat box, sir.
Sure.
Yeah, hello.
Yes, sir. Yes, sir. I can.
Yes, sir. Can I have a question real quick?
Yeah, please ask me the question.
All right, sir. My question concerning the lower class of society, because now, from I understand from your point of view, is the new jobs that will be generated is people who are in the field of engineering or science or doctors learn to do data and create this artificial intelligence to, take over other jobs. But my concern is, wouldn't that kind of wipe the lower class who can't afford the same resources as the engineers and doctors? Like, for example, cops, the janitors, they wouldn't be able to afford to make intelligent, AIs based on their work job. So that would kind of make them jobless, since they can't afford to do the same as the doctors and engineers who have a bit higher, standard when it comes to creating this sort of stuff. And my other question is, can maybe like data engineers cooperate with people who work in the field, so we can like make some cooperation happen where we can make the AI that way, so it wouldn't take as long to learn your specific field, get expertise, then also learn AI engineering, data engineering, which would maybe take a long time to get right. That's my question, sir.
Sure. So the first question, I think the people who's not up to the level that what we are talking about, people who understand science, people who understand math, people who understand machine learning, all the things, of course, there's a huge volume of people, huge amount of people out there. So this is where the policy will going to define. Okay. So what does that mean? If someone's jobs is going to take away, let's say we are going to take out just taking a hypothetical example, accountant, finance and accounting. So most of the finance and accounting rules are, I'm not saying easy, it's quickly automatable, correct? How does a balance sheet is going to look? An assets equal to liability, not a rocket science, correct? We can do that. All right. So doing such automation may bring people like accountant, people like finance people lose their jobs, correct? If that happens, what happened to those people, correct? I think that's your question. You can't upskill them because their skills are not learning machine learning, understanding deep learning, understanding data engineering. They may not be able to do that, correct? So this is where the policy comes into picture. So when I say policy, the government will step up forward and create some kind of a guidelines, governance structure. How do we retool these people? And where these people is going to be deployed, correct? So that is not in your hand, that is not in my hand, correct? So we are going along with the crowd. We are not policymakers, but we can write to the policymakers. We can tell the policymaker these are the things should be done before even going too broad. I think there is a governance body each and every country, and that is how I understood. That's what I see. Every country, every state, every city, there is a governance structure expected to formalize around artificial intelligence that falls under guiding principles of how to do certain things, what to do under circumstances, things like this. Correct? It is not there, but it will come. That's my take on that one. Okay. The second question you asked, could you mind to repeat the second question because I'm kind of lost?
Yes, so my second question, because from what I got from your lecture is, there'll be new phases for studying. First you should study your course, maybe like being a doctor, then you must have expertise, then you have to study data engineering. That will be the new way. But is it possible to have like just a plain doctor cooperate with a data engineer, like 2-person team, and then make the AI based on that?
Sure. The roles of data engineer, the roles of doctor, actually, all the things are basically like, it's based on how the actual, like for example, so I'm currently in a project where the conversation that takes place, a patient and a doctor, correct? You go to a hospital, I'm a patient, you are a doctor, we both speak. So my job as a scientist, understand what you both are spoke, record the conversation. Once I record the conversation, then from the conversation, I extract the text, what you spoke. From the text, I create a medical transcript. From the text, I analyze what symptoms and warnings that you spoke, correct? So if you noticed, I'm not a doctor. I never had any medical degree. I never went to any medical school. But all I'm doing actually, I'm basically using the machine to learn and understand what has been spoken, what most frequently spoken, how many times it's been spoken, what symptoms I see this one. So I am taking previous conversation and making the machine to learn and understand and extract. In this case, what is my skill? My skill is more for analytical. My skills more of working with large complex data sets. Correct? I don't have to be a medical doctor. I don't have to have a PhD. I don't have to have any advanced degrees. Correct? All I have to understand, how do I work with very large complex data sets, and how do I train and teach the machine to understand what is in the data sets. Correct? I think that is the skill set that's required. So if you are working with in a medical field or any other field, correct? There is no expectation that you have to interact with the doctor, you have to get to know. It's good to interact, but the main focus is working with large complex data sets and teaching the machine. That's the expectation. Okay. So who can work with the large complex data sets? That typically data engineer. But sometimes what happens, the data engineer, data scientist could be the same person. What happens, correct? If you're a data scientist, you don't understand data engineering, then you may not be able to build right model. You may not be able to train the model quickly, get that good accuracy, correct? Why? Somebody else doing the data engineering part, because data plays a key role. So if a model is not performing well, if model is, the prediction of the model is not highest confidence level, it's very low confidence level, the probability is very low. You know what data is working, what data is not working. You can go and change this one. If that is done by somebody else, it could be quite challenging. So there are pros and cons on what you said.
Thank you, sir. We have a few questions in the chat box.
Thank you, sir. This was Akil Mahmoud from IUKL.
Sir, we have few questions in the chat box. One is from Rupashri of NCA from SRMIST.
Yeah, so I can answer Rupashri later. So
Okay.
she's actually with us. Yeah, she's doing her project actually. I saw the question actually. She wants to do active or something.
Yeah. We have another question.
How do we protect access to AI from bad actors? Correct.
Yes,
So
yes.
I'm not sure what exactly protecting access from AI from bad access. So technically anything can be done. We just have to understand what exactly we are trying to do and do it actually. Like, so Rupashri, I'll answer this question. No worries.
Thank you, sir. Another
Anything
question from Mr. Mohammed. Could AI hinder human creativity? And since development, new ideas can come from machines, even if they are intelligent.
Yes, absolutely. So, like the best example that you could think of, like, so if you all noticed, we never call a music director as a creator. It's a music composer, right? If you look at any music person who composes music, we call them composer, not a creator. So what exactly that means? They mix many different tunes, many different things, and come up with a unique approach, correct? So that is the actual mixing. That's a composing, correct? Same for a machine too. So the machine can learn and understand
different aspects to a problem, which we may not know exactly. Why? We stay at a high level. The machine go to the root, deepest level through data. It sees the different patterns. It comes up with a different recommendation, correct? Example, correct? For example, how does the recommendation system works in Amazon, correct? It looks at the behavior. It looks at like, where you are going, what product you're looking at for a long time. It looks at how much money you spend. It looks at how many times you're buying in a week or a month or a day, correct? It looks at all different dynamics. We as a human may not know all the things for every customer in a large customer base, correct? So the machine understands all the behaviors of a customer, then it makes a recommendation. So definitely the machine goes to much higher advanced level based on the type of data it sees, what it sees in the data sets, then it makes a recommendation. So that would say gives more opportunity for solve problem, more solution for problems, more opportunity for creating something new, innovative.
Okay, sir. Can we go for two more questions? Is there?
Yes, sir. Yeah,
One
we'll
is,
take two more questions.
yeah, this is from Hasnan. May I know your opinion on Neuralink from ethical standard? Neuralink from ethical standard. Neuralink.
See, ethical, yeah. So from ethical standpoint of view, like I said, like, there's a lot of undefined territories, correct? Like, so there's no defined guideline, there is no defined principles, there's no defined policies, correct? So it would be so difficult to say what it is, how it is, because I myself not involved in the ethical side. I don't work on the ethical side at all, correct? So the ethical AI, as I said, at a higher level, putting governance, putting structures, correct? What is good cause, what is bad cause, what is good for people, what is not good for people, what is good for public, what is not good for public, defining all such things. That's more of a policy maker. So I'm not involved. I wouldn't be able to answer that question.
I'll make it as one more question.
Sure,
Could AI hinder human creativity and science development? New ideas cannot come from machines, even if they are intelligent. So this is the question posted by Al-Mahari Muhammad.
Sure, I would disagree. I would say that when, like I said, like, we as a human have only so much. Just give you an example, correct? I'm a doctor. I'm diagnosing a patient disease condition, correct? Let's take an example. I'm diagnosing disease condition of diabetes. So now I want to tell that the patient, try this medicine. I'm not joking, correct? Many doctors are doing trial and error. Many doctors are doing trial and error. Try this medicine. If it works, great. If it doesn't work, that's fine. But as a machine, what happens? It looks much deeper. Okay. As a doctor, you know who are the patient you treated, or what you studied, or the people who are in network. So that means your knowledge, your vision, or your innovation limited to what you know, limited to the people you know, limited to the things that what you studied. But a machine is not like this. So let's say my patient, it's a Chinese or an Indian at the age of 40, male. So now across the world, I can take all Indians, I can take all Chinese at the age of 40, male, and see what kind of symptoms they have, what medicine worked, what medicine not worked, correct? So machine can go that deepest level. A doctor cannot go that level. I would disagree that on that question, like, the machine cannot go beyond the creativity of a human. I would disagree with that. It based on what kind of creativity we're talking, it varies, correct? The example I gave you, that is proven, correct? Yeah, machine can do a better job than a doctor. Example, as a doctor, you know only what you studied, or you know only the case you worked on, or you know the journals you published, or you know the network of people you know. But machine goes beyond all the things. It goes beyond all the things. Let's assume in the world we have 50 million people who has diabetes, who has taken treatment. If you give that much data, it learns and comes and tells you, this is a medicine worked for this patient condition, which a doctor cannot even predict.
Thank you, sir.
Time is up, Krishnamurthy, sir.
Yes, sir. Yes, sir.
So, okay, finish the session and we go for vote of thanks.
Thank you, sir. Thank you for a wonderful session. May I now invite Ms. Jabashini Pondian and Dr. J. Dilipan, Vice Principal, Academic, Faculty of Science, University of Ramapuram, and Ms. Jabashini Pondian, Lecturer, Department of Electrical and Electronics Engineering, IUK, Kuala Lumpur, to present the vote of thanks. Please, sir and madam.
Hello.
Jabashini Pondian, yes, ma'am.
Yes, ma'am.
Hello. Okay. A big thank you to Mr. Jyoti Parisamy, Chief Data Scientist, USA, for your efforts towards AI with real-world application. Really, it's a very, very useful talk for our students and also SRM engineering students. As everybody knows, AI is upcoming concept in Industry Revolution 4.0. So it's common to both computer science and electronics department, I feel. So for electronics engineering also, how AI is combined with IC chip design, and then how automatic cars are driving using the IC chip that is holding programs inside the IC, like that. So we want to hear more news about this in future from you, sir.
Sure, ma'am. Actually, I will share you quickly. So we already have an article published. You can see. So I'm going to share my screen really quick. So if you could go to our website, so in our website we have an article published on autonomous car. So you can see that one that has complete full scale. So this is basically publication. Under publication, you can see reinforcement machine learning. Select this one. So this is basically how to build autonomous cars, right? So this is talks about. Okay, 1 second.
Madam, you please proceed, madam.
Okay.
Sir, shall we wait, sir?
No, that's fine, sir.
Okay.
You can.
Okay, so hopefully we will get those information soon from you. Okay, sure, all the participants are benefited from this professional talk. And I also wish to express my gratitude to our Dean IR Nasir for providing such encouragement at this professional talk series. I think we have conducted so many professional talk already in the midst of his busy schedule. And thank you, Mr. Jason. You are with us from starting of MOU. Hope you will be with us to move forward to the next stage in the year 2021. And my special thanks to Dr. Dileepan, Vice Principal, Academic, SRM Institute of Science and Technology, to organize this professional talk. And definitely, he put a lot of efforts to make this event successful. Whenever he called me, and we both worked together, and then sure, this will be useful on both sides. Hope his next project with IUKL, the International Joint Conference, will be launched soon. We are also expecting that.
Yes, madam. Thank you, madam. Thank you, madam.
Thank you so much to all the deans, heads, lecturers, students from SRM side also. I can see a lot of participants. And we also acknowledge Madam Hafiza, Head of Department IT, IUKL, to give all the support on time to make it successful. And finally, thank you so much for all the participants, those who have attended this session. Hope you can get a maximum knowledge from this topic. Now I hand over to Dr. Dileepan to extend few points from SRM side. Thank you.
Thank you, madam. Good afternoon, one of the present here. On behalf of SRM Minister of Science and Technology, I take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to this webinar on applied artificial intelligence, organized by Department of Computer Science and Applications, SRM Ramapuram campus, in association with Infrastructure University, Kuala Lumpur. At the outset, I thank our chief guest and resource person, Mr. Jyoti Periyasamy, for his wonderful session. We are really enlightened with your knowledge and presence, sir. Thank you so much, sir. We are thankful to our Honorable Director, Dr. V. Subbaya Bharati, for delivering presidential address and also for your valuable support in all our academic activities. I take privileges in honoring IR Muhammad Nasir Hussain, Dean IUKL, for giving felicitation address. Thank you for your valuable presence, sir. I would like to thank our principal, Dr. C. Sundar, for his enthusiastic support, dedication, and motivation. Thank you, sir. Next, I would like to thank Mr. Jason, Head of International Linkages and Special Projects from IUKL, and Dr. Abraham, Associate Dean, International Relations from SRM IST, for your valuable presence. A special thanks to the Dr. Jabasani Madam for coordinating this event from IUKL, and event coordinator from our side, Professor N. Krishnamurthy, and faculty members for their unflinching support and coordination. Our heartfelt thanks to our students from SRM IST and from IUKL for your active participation. So with these warm words and a kind message, now we are moving to the end of the today's session. Thank you all.
Thank you. Thank you, sir.
Thank you,
for
sir.
your-
Thank you very much.
Thank you, sir. And
Thank you.
for
Bye.
your wonderful credentials.
Thank you. It was a wonderful event. Thank you.
Thank you, sir. Thank you. Thank you. Thank you.
Thank you, Jason. Thank
See
you.
you.
Bye.
So
See you all.
next, we will have the joint conference with IUKL in the month of April, May.
Okay.
It'll be a
Thank you,
great
sir.
event. Looking forward.
Yes,
to
sir.
it.
Yes,
Looking
sir.
forward.
Thank you, sir.
All right. Thank you. Bye.
Bye.
Thank you, sir. Thank you. Thank you. Bye. Bye. Thank you, Jyoti, sir. Thank you, madam. Thank you, madam.
Thank you. Have a great
Thank you, sir. Thank you, director, sir.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir.
Hello, sir.
Dr. Abraham is not here.
Dr. Abraham, thank you, doctor, for your cooperation.
Thank you all, madam.
Thank you, sir. Dilipan.
Madam Nasrin,
Yeah.
is Hafiza there? No.
I cannot see her.
Madam Hafiza. Oh, because Dr. Dilipan wants to meet her.
Oh, okay. Maybe can meet because this is live on YouTube, right?
Okay. Yeah, yes.
Thank you, madam. There is a feedback link available in the chat box. Can you?
Yeah,
Ask-
already filled in the feedback form.
Yeah, you can pass it to your students and faculty members who are attending.
Yeah, sure. Sir, you're Krishnamurthy,
Yeah,
right?
yeah, I'm Krishnamurthy.
Nice to meet you, sir. Thank you so much. Thank you so much
Thank
for
you,
your
ma'am.
help.
Thank you,
Thank you,
sir.
sir.
Okay, thank you.
Good day. Is anybody there? Can I end the meeting? Thank you all for joining. Thank you. With your permission, let me end the meeting. Thank you all.
Thank you.
Thank you. Have a good day. Thank you.
You too.
Thank you. Same thing, madam.
Thank you so much. Thank you.
Thank you. Thank you. Thank you. Thank you. Thank you. Thank you all. I'll end the meeting now.